voy a hacer una pequeña introducción y vamos a arrancar con el curso de hoy de Machine Learning de Stanford, ¿sí?
Hola, buenas tardes. Mientras esperamos que se conecten algunos más, soy Javier Escodelaro y quería agradecerles por conectarse y participar, bueno, de las actividades que siempre acá se están organizando para presentar material nuevo, cosas nuevas y, bueno, siempre fundamentalmente relacionado con inteligencia artificial. Así que, bueno, les agradezco por participar. Espero que les guste el curso y puedan participar activamente.
Esto va a quedar grabado en YouTube, pero además es un curso de Coursera, ¿sí? Y si ustedes quieren acceder a Coursera, tenemos planes del Centro Graduados mucho más económicos que los de Coursera para poder entrar y obtener un certificado oficial de la Universidad de Stanford. Eso les vamos a contar ahora. Bueno. Muy bien. Bueno, me voy a presentar, voy a contarles rápidamente de qué se trata la institución que está organizando esta actividad y también, también vamos a hablar un poquito del curso de qué es lo que hacemos del Centro de Graduados. Les voy a pasar un link al grupo de WhatsApp. Los que quieran seguir participando, seguir conectados, compartiendo material, y ahí les paso el grupo de WhatsApp. La idea es que si ustedes quieren dar el presente por ahí, poniendo su nombre y apellido, puede ser perfectamente. Creo que está Yasmín acá tomando los presentes. Bien, me presento. Señores, muy buenas tardes. Ya los saludó y les doy la bienvenida al presidente de la institución, Javier Escodelaro, que está encargado del canal de YouTube, es el que administra el canal de YouTube. Mi nombre es Ariel Alegre, yo estoy a cargo del área de capacitación, coordino el área de capacitación del Centro de Graduados de Ingeniería de la Universidad de Buenos Aires. Somos una asociación civil de Argentina, pero en ese sentido somos totalmente abiertos a nivel del lugar, no es imprescindible ser de Buenos Aires ni de Argentina, cualquiera puede participar, tampoco hace falta ser graduado de Ingeniería ni de la Universidad de Buenos Aires, es una asociación totalmente abierta a la participación, y bueno, están todos bienvenidos y obviamente que siempre se está necesitando colaboración, gente que quiera sumarse, participar en las actividades que estamos haciendo. Básicamente nosotros tenemos un foco muy fuerte puesto en temas relacionados con la tecnología, con difundir la tecnología, con poder ayudar a la gente, a la sociedad en general, a acceder en forma lo más fácilmente posible al conocimiento, y por eso es lo que vamos a hacer hoy, de compartir esta actividad de hoy. En particular, nosotros venimos trabajando muy fuertemente con todos los temas relacionados con inteligencia artificial, Python, Machine Learning, Big Data. Digamos, tenemos mucho foco puesto en eso, hemos creado una cooperativa de trabajo, y bueno, Carla es una de las personas que está participando en nuestros grupos de desarrollo activamente. ¿No, Carla? ¿Estás por ahí?
Sí, así es.
Vos empezaste hace poquito, ¿no? Hace pocos meses.
Sí, fines del año pasado recién.
Ya estás integrada al grupo de Computer Vision, que están desarrollando un sistema de visión artificial de detección de infracciones de tránsito.
Exacto.
Bueno, básicamente les cuento, nosotros desde el Centro de Graduados hemos contratado el Plan Team de Coursera, que el Plan Team permite que, como las licencias son transferibles, digamos, comprando un paquete relativamente reducido de licencia lo puede usar mucha gente, entonces el precio se diluye. Coursera les cobra por usar el Plan Team aproximadamente $60 por mes. Lo pueden encontrar buscan Coursera Plus en internet y lo van a ver. Nosotros, digamos, abonando una tarifa bastante menor que eso, bastante más pequeña que eso, pueden acceder a Coursera, son casi 10.000 cursos que hay, y pueden obtener certificados oficiales de las mejores universidades del mundo, Stanford, como este curso, y de Google, de empresas como Google, Facebook o como IBM. Todos esos cursos están disponibles. Es algo realmente interesante y nosotros mostramos mucho, ¿no? O sea, damos cursos dados por nuestros docentes, con material preparado por nosotros, pero ya hace varios años tenemos foco en este tema de Coursera porque realmente es material muy bueno y nosotros lo que hacemos es coordinarlo, es decir, presentarles una opción para que ustedes puedan acceder a estos materiales y además formar el grupo. O sea, lo interesante es que se forma un grupo, que ustedes pueden ahí consultar, pueden aportar cosas, agregar. Eso es lo que tiene de interesante esto. Creo que se acaba de conectar también Emiliano Pasarello, y me gustaría darle la bienvenida. Él creo que viene a hacer un aporte, ¿sí? Porque el curso de hoy es un curso que está en inglés, con subtítulos en inglés. Y creo que Carla y Emiliano, no sé bien qué hicieron y consiguieron tenerlo con subtítulos en español, así que se los vamos a compartir. Yo voy a compartir pantalla en este momento. Les voy a contar de qué se trata la actividad de hoy. Pantalla. Voy a compartir sonido. Lo que vamos a hacer básicamente, fíjense, este curso que se acaba de editar, actualmente se acaba de editar, es el curso de Machine Learning de Andrew Ng, que es un curso tradicional que existe hace más de 10 años, pero que él lo había hecho con Octave, con otra herramienta, y además un curso que ya está bastante viejo, muy bueno, y ahora lo acaba de reeditar todo, lo acaba de actualizar, dar todo en Python, y ha mejorado muchísimo. Es algo bien para empezar de cero, para entender todos los conceptos, y son 3 cursos. Este de aprendizaje automático supervisado, después tenemos el de algoritmos avanzados, donde ahí vamos a ver fundamentalmente redes neuronales, y después aprendizaje no supervisado, sistemas de recomendación y aprendizaje reforzado, ¿sí? Entonces, realmente es todo un pantallazo y todo un curso muy, muy conceptual sobre Machine Learning, que es el tema que está creciendo mucho, que está viendo mucha demanda, el tema de análisis de datos, de Big Data, todos estos temas, y como les decía, es una especialidad nuestra en el Centro de Graduados. Pero básicamente lo que vamos a hacer hoy, vamos a ingresar a este curso 1, ¿sí? Y vamos a ver y hacer los ejercicios de la semana 1, ¿sí? La semana 1. Es un curso de 3 semanas, por eso les contaba que todos los que tengan interés en tener acceso, abonando una tarifa realmente muy accesible, van a poder hacerlo. Les voy a pasar el link para los que quieran sumarse al grupo de WhatsApp para seguir en contacto nosotros. Les voy a pasar al grupo de YouTube, que hay 14 personas, así que ahí va, para YouTube está el WhatsApp, y para acá, para la call. ¿Se escucha? Buenísimo. Bueno, básicamente yo con eso terminé con mi introducción, así que sin mucho más preámbulo, lo que voy a hacer es pasar los videos. Igual lo que les quiero contar, que ahora les voy a dar el pie a Emiliano y a Carla, que ustedes cuando ven estos videos, ¿ven que está en inglés?
Welcome to machine learning. What is machine learning? You probably use it many times a day without even knowing it. Anytime you want to find out something like, how do I make a sushi roll?
No sé, Emiliano, si estás por ahí, nos querés pasar el link. Yo no lo hice nunca.
Hola, ¿qué tal? Buenas tardes a todos, un gusto. Sí, te paso un link y fíjate si lo podés abrir vos, si no...
Vale, voy a probar, voy a probar.
¿Te lo paso por WhatsApp o crees que se lo pase directamente?
Acá por el grupo.
Bueno, esperá un segundito entonces. Ahí va, ahí va.
Bueno, así que hoy en realidad Emiliano vino a hacer este aporte. Él ya estuvo dando clase a la mañana, Y me imagino que hace un toque me voy porque yo tengo esa costumbre de tirarle los cursos a los colaboradores y Emiliano, de hecho, es un gran colaborador del Centro de Graduados. Ahí va, gracias Emiliano.
Te lo pasé, a ver.
¿Esto cómo es? ¿Los tradujeron ustedes estos?
Sí, descargué los subtítulos en inglés porque eran los únicos que habían en ese momento, que hace poquito, una semana, 2 semanas atrás. Y descargamos y con Carla estamos traduciendo todo el curso, solamente los videos no, sino los laboratorios, todo. Ahí vas esa es la semana 1. La semana 1, como ves, que está dividida en Coursera, está dividida por secciones, ¿no? Está dividida la sección 1, 2, 3 y 4. En cada carpeta está cada video que supuestamente, si vos le das play en el Drive, por ejemplo, en la 1.
Acá, la 1.
Esa es la sección 1, ve que tiene 2 videos. Welcome, ahí tenés el MP4. Si vos ejecutás el MP4, no, el MP4. No, ese cancela.
Acá.
El MP4. Claro.
Bueno, buenísimo, gracias. Gran aporte acá de Emiliano Pasarello y Carla Pesone. Así que bueno, vamos a ver, exclusivo del Centro de Graduados, con videos subtitulados en español. ¿Sí? Es un gran curso realmente, es muy didáctico, así que para todos los que quieran iniciarse en el tema, es muy bueno. Así que bueno, vamos a empezar casi ya mismo, les diría. Hay 40 personas conectadas y hay unas 20 en YouTube. ¿Hay preguntas? ¿Alguien tiene dudas? ¿Quiere comentar algo? ¿Preguntar algo? Porque la idea, tenemos una tarde intensa con mucho material, es una semana larga, así que quisiera empezar cuanto antes. ¿Alguien tiene alguna pregunta? ¿Tiene alguna duda? ¿Algún comentario que hacer? ¿Todos quieren escuchar? ¿Nadie tiene preguntas ni dudas? Bueno, arrancamos entonces. Pónganme que sí, por favor, acá por el chat. Porque es feo escribir. Bueno, dale. Arrancamos entonces. Igual, si hay dudas o preguntas, me escriben ahí en el chat o en algún momento cortamos. ¿Tiene certificado? Bueno, sí, justamente nosotros tenemos un plan que es muy económico. Hemos mantenido el precio en pesos a pesar de la devaluación en pesos argentinos. Y digamos, teníamos un precio de 3.000 pesos argentinos por mes, que uno lo paga por mes, que se paga por Mercado Pago, que hace 2 semanas eso eran $15, y hoy son 10. Y lo hemos mantenido, no sé por cuánto tiempo lo vamos a mantener. Le piden a Yasmín, ¿sí? No sé si estás ahí, Yasmín, o paso tu celular, ¿querés? Le voy a pasar el celular de Yasmín. Y le hablan a Elia, o a Emiliano. Está ahí también Emiliano, ¿no? Bueno, lo que quiero que sepan que además nos ayudan a poder seguir manteniendo esto, ¿no? El link de video de YouTube donde se está reproduciendo. Ahí va. No, ahora lo estoy reproduciendo en un Drive, pero lo acabamos de pasar el link. Después, si quieren, se los paso otra vez, el Drive. Pero si no, es en Coursera. Lo encontrás en Coursera. Bueno. Bueno, le quiero dar la bienvenida especial a un amigo que se acaba de conectar, que hace tiempo que no lo veía, Walder Guío. El Drive tiene la primera semana del curso, claro. Bueno, arrancamos entonces, donde básicamente lo que hicieron fue traducir los subtítulos. ¿Qué tal, Walder? ¿Cómo estás? Gustazo verte. Bueno, veo un montón de gente conocida, otros que no conozco. Bienvenidos a todos. Arrancamos.
Welcome to machine learning. What is machine learning? You probably use it many times a day without even knowing it. Anytime you want to find out something like, how do I make a sushi roll? You can do a web search on Google, Bing, or Baidu to find out. And that works so well because their machine learning software has figured out how to rank web pages. Or when you upload pictures to Instagram or Snapchat and think to yourself, I want to tag my friends so they can see their pictures. Well, these apps can recognize your friends in your pictures and label them as well. That's also machine learning. Or if you've just finished watching the Star Wars movie on the Buenos Aires streaming service and you think, what are the cinema movies that I watch? Well, the streaming service will likely use machine learning to recommend something that you might like. Each time you use voice-to-text on your phone to write a text message,
Hey Andrew, how's it going?
Or tell your phone, hey Siri, play a song by Rihanna. Or ask your other phone, okay Google, show me Indian restaurants near me. That's also machine learning. Each time you receive an email titled, congratulations, you've won $1 million. Well, maybe you're rich, congratulations. Or more likely, your email service will probably flag it as spam. That too is an application of machine learning. Beyond consumer applications that you might use, AI is also rapidly making its way into big companies and into industrial applications. For example, I'm deeply concerned about climate change, and I'm glad to see that machine learning is already helping to optimize wind turbine power generation. Or in healthcare, it's starting to make its way into hospitals to help doctors make accurate diagnoses. Or recently, at Learning.AI, I've been doing a lot of work putting computer vision into factories to help inspect if something coming off the assembly line has any defects. That's machine learning. It's the science of getting computers to learn without being explicitly programmed. In this class, you learn about machine learning and get to implement machine learning in code yourself. Millions of others have taken the earlier version of this course, which is a course that led to the founding of Coursera, and many learners ended up building exciting machine learning systems or even pursuing very successful careers in AI. I'm excited that you're on this journey with me. Welcome, and let's get started.
Bueno, para los que no conocen, este muchacho que está hablando es Sandro Ng, un capo total. Dirigió equipos técnicos de Deep Learning, de Machine Learning en Google, después en Baidu, y ya hace varios años que dijo, yo me quiero dedicar a formar gente, a evangelizar, y bueno, creó Coursera y tiene una empresa que se llama DeepLearning.AI con varios cursos, ¿sí? Les escribo acá, es DeepLearning. Es impresionante la velocidad que tiene para sacar cursos. No llegamos a hacerlos todos, tratamos de hacerlos todos, pero no llegamos por la cantidad que tiene de cursos nuevos, de temas apasionantes que está sacando. Y, y además creó una empresa, Lending.AI, donde también está dando servicios en inteligencia artificial. Así que bueno, la realidad es que en el Centro de Graduados la mayoría de nosotros nos consideramos discípulos de Andrew Ng, seguimos estos cursos y bueno, realmente muchos de nosotros ya también estamos trabajando en estos temas gracias a la formación que recibimos con Andrew en Coursera. Les voy a pasar a todos otra vez el grupo de WhatsApp, por si quieren sumarse al grupo, estar presente por ahí. Ahí va el enlace. Y lo mando también a YouTube. Disculpen los de YouTube si no estoy... Ah, bueno. Ahí ya recibieron. Bueno, bárbaro. Ahí les mando el link al grupo. Y seguimos con la semana... Con la clase 2, perdón, de la semana 1. Bueno, vamos con aplicaciones de Machine Learning. ¿Sí? Que es esta que está acá. Esta aplicación de Machine Learning.
In this class, you learn about the state of the art and also practice implementing machine learning algorithms yourself. You learn about the most important machine learning algorithms, some of which are exactly what's being used in large AI or large tech companies today, and you get a sense of what is the state of the art in AI. Beyond learning the algorithms, though, in this class, you also learn all the important practical tips and tricks for making them perform well, and you get to implement them and see how they work for yourself. So, why is machine learning so widely used today? Machine learning had grown up as a subfield of AI, or artificial intelligence. We wanted to build intelligent machines, and it turns out that there are a few basic things that we could program a machine to do, such as how to find the shortest path from A to B, like on your GPS. But for the most part, we just did not know how to write an explicit program to do many of the more interesting things, such as perform web search, recognize human speech, diagnose diseases from X-rays, or build a self-driving car. The only way we knew how to do these things was to have a machine learn to do it by itself. For me, when I founded and was leading the Google Brain team, I worked on problems like speech recognition, computer vision for Google Maps Street View images, and advertising. Or leading AI at Baidu, I worked on everything from AI for augmented reality to combating payment fraud to leading a self-driving car team. Most recently, at Landing AI Fund and at Stanford University, I've been getting to work on AI applications in manufacturing, large-scale agriculture, healthcare, e-commerce, and other problems. Today, there are hundreds of thousands, perhaps millions of people working on machine learning applications who could tell you similar stories about their work with machine learning. When you've learned these skills, I hope that you too will find it great fun to dabble in exciting different applications and maybe even different industries. In fact, I find it hard to think of any industry that machine learning is unlikely to touch in a significant way now or in the near future. Looking even further into the future, many people, including me, are excited about the AI dream of someday building machines as intelligent as you or me. This is sometimes called Artificial General Intelligence, or AGI. I think AGI has been overhyped, and we're still a long way away from that goal. I don't know if it'll take 50 years or 500 years or longer to get there, but most AI researchers believe that the best way to get closer toward that goal is by using learning algorithms, maybe ones that take some inspiration from how the human brain works. You also hear a little more about this quest for AGI later in this course. According to a study by McKinsey, AI and machine learning is estimated to create an additional $13 trillion of value annually by the year 2030. Even though machine learning is already creating tremendous amounts of value in the software industry, I think there could be even vastly greater value that is yet to be created outside the software industry in sectors such as retail, travel, transportation, automotive, materials manufacturing, and so on. Because of the massive untapped opportunities across so many different sectors, today there is a vast, unfulfilled demand for this skill set. That's why this is such a great time to be learning about machine learning. If you find machine learning applications exciting, I hope you stick with me through this class. I can almost guarantee that you find mastering these skills worthwhile. In the next video, we'll look at a more formal definition of what is machine learning. And we'll begin to talk about the main types of machine learning problems and algorithms. You pick up some of the main machine learning terminology and start to get a sense of what are the different algorithms and when each one might be appropriate. So let's go on to the next video.
Bueno, a ver, ya vimos esta primera parte, ahora viene esta otra, la de la comparación entre aprendizaje automático supervisado y no supervisado. O sea, tendría que haber una carpeta con 1, 2, 3, 4, 5 videos y este laboratorio donde empieza con los laboratorios. Estos laboratorios no están accesibles si ustedes lo ven en forma gratuita. Hay una opción que ustedes ponen audit de curso. Entonces los videos estos son públicos en Coursera. No son públicos los labs, ni el certificado. Bueno, vamos a seguir entonces. A ver. Semana 1. Miren la parte 2. Ahí está. Bueno, le vuelvo a agradecer para los que llegaron recién a Carla Pesoni y Emiliano Pasarelo que tuvieron disponibles para hoy los subtítulos en español. Me voy a mutear y seguimos entonces con... ¿qué viene ahora? ¿Qué es Machine Learning? Ahí está, what is Machine Learning?
So, what is machine learning? In this video, you learn a definition of what it is and also get a sense of when you might want to apply it. Let's take a look together. Here's a definition of what is machine learning that is attributed to Arthur Samuel. He defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Samuel's claim to fame was that back in the 1950s, he wrote a checkers playing program. And the amazing thing about this program was that Arthur Samuel himself wasn't a very good checkers player. What he did was he had programmed a computer to play maybe tens of thousands of games himself. And then by watching what sorts of positions tend to delete their wins and what positions tend to delete their losses, the checkers playing program learned over time what are good or bad board positions. By trying to get to good and avoid bad positions, his program learned to get better and better at playing checkers. Because the computer had the patience to play tens of thousands of games against itself, it was able to get so much checkers playing experience that eventually it became a better checkers player than Arthur Samuel himself. Now, throughout these videos, besides me trying to talk about stuff, I'll occasionally ask you a question to help make sure you understand the content. Here's one about what happens if the computer had played far fewer games. Please take a look and pick whichever you think is a better answer. Thanks for looking at the quiz. And so if you had selected this answer, would have made it work.
Ahora tengo que entrar acá y poner la pregunta, porque esto es Coursera.
So, what is had played far fewer games? Please take a look and pick whichever you think is a better answer.
Nos pregunta, a ver, si el programa que hizo Arthur Samuel de jugar a las damas, se le hubiera permitido jugar solamente 10 juegos, en vez de decenas de miles de juegos, contra sí mismo. ¿Cómo habría afectado esto su rendimiento? ¿Hubiera sido peor o hubiera sido mejor? Bueno, el primer examen, a ver si están prestando atención, hubiera sido peor, dice Andrea. ¿Están todos de acuerdo que la respuesta es que hubiera jugado peor? ¿Una sola? Sí, sí, bueno. Tenemos dos respuestas. Me gusta que participen, ¿eh? A ver.
Worse, then you got it right. In general, the more opportunities you give a learning algorithm to learn, the better it will perform. If you didn't select the correct answer the first time, that's totally okay too. The point of these quiz questions isn't to see if you can get them all correct on the first try. These questions are here just to help you practice the concepts you're learning. Arthur Samuel's definition was a rather informal one, but in the next two videos, we'll dive deeper together into what are the major types of machine learning algorithms. In this class, you learn about many different learning algorithms. The two main types of machine learning are supervised learning and unsupervised learning. We'll define what these terms mean more in the next couple of videos. Of these two, supervised learning is the type of machine learning that is used most in many real-world applications and that has seen the most rapid advancement and innovation. In this specialization, which has 3 courses in total, the first and second courses will focus on supervised learning, and the third will focus on unsupervised learning. You might have also heard of reinforcement learning. This is another type of machine learning algorithm that I'll talk about briefly. But by far, the two most used types of learning algorithms today are supervised learning and unsupervised learning. That's why we'll spend most of this class talking about them. The other thing we're going to spend a lot of time on in this specialization is practical advice for applying learning algorithms. This is something I feel pretty strongly about. Teaching about learning algorithms is like giving someone a set of tools. And equally important, or even more important than making sure you have great tools, is making sure you know how to apply them. Because, what good is it if someone were to give you a state-of-the-art hammer or a state-of-the-art hand drill and say, good luck, now you have all the tools you need to build a 3-story house? It doesn't really work like that. And so too in machine learning, making sure you have the tools is really important. And so is making sure that you know how to apply the tools of machine learning effectively. So that's what you get in this class, the tools as well as the skills of applying them effectively. I regularly visit with friends and teams in some of the top tech companies. And even today, I see experienced machine learning teams apply machine learning algorithms to some problems. And sometimes they've been going at it for 6 months without much success. And when I look at what they're doing, I sometimes feel like I could have told them 6 months ago that the current approach won't work. And there's a different way of using these tools that will give them a much better chance of success. So in this class, one of the relatively unique things you learn is you learn a lot about the best practices for how to actually develop a practical, valuable machine learning system. This way, you're less likely to end up in one of those teams that end up losing 6 months going in the wrong direction. In this class, you gain a sense of how the most skilled machine learning engineers build systems. And I hope you finish this class as one of those very rare people in today's world that know how to design and build serious machine learning systems. So that's machine learning. In the next video, let's look more deeply at what is supervised learning and also what is unsupervised learning. In addition, you learn when you might want to use each of them, supervised and unsupervised learning. I'll see you in the next video.
Bueno, vamos a seguir con el siguiente video.
So, what is machine learning?
Que vendría a ser este. Aprendizaje supervisado, parte 1. ¿Sí? Supervised Learning, parte 1. Este.
Machine learning is creating tremendous economic value today. I think 99% of the economic value created by machine learning today is through one type of machine learning, which is called supervised learning. Let's take a look at what that means. Supervised machine learning, or more commonly supervised learning, refers to algorithms that learn X to Y or input to output mappings. The key characteristic of supervised learning is that you give your learning algorithm examples to learn from that include the right answers, where by right answer, I mean the correct label Y for a given input X. And is by seeing correct pairs of input X and desired output label Y that the learning algorithm eventually learns to take just the input alone without the output label and gives a reasonably accurate prediction or guess of the output. Let's look at some examples. If the input X is an email and the output Y is this email spam or not spam, this gives you your spam filter. Or if the input is an audio clip and the algorithm's job is to output the text transcript, then this is speech recognition. Or if you want to input English and have it output the corresponding Spanish, Arabic, Hindi, Chinese, Japanese, or something else translation, then that's machine translation. Or the most lucrative form of supervised learning today is probably used in online advertising. Nearly all the large online ad platforms have a learning algorithm that inputs some information about an ad and some information about you, and then tries to figure out if you will click on that ad or not. Because by showing you ads that you're slightly more likely to click on, for these large online ad platforms, every click is revenue. This actually drives a lot of revenue for these companies. This is something I've once done a lot of work on, maybe not the most inspiring application, but it certainly has a significant economic impact in some companies today. Or if you want to build a self-driving car, the learning algorithm would take as input an image and some information from other sensors, such as a radar or other things, and then try to output the position of, say, other cars, so that your self-driving car can safely drive around the other cars. Or take manufacturing. I've actually done a lot of work in this sector at Landing.AI. You can have a learning algorithm takes as input a picture of a manufactured product, say a cell phone that just rolled off the production line, and have the learning algorithm output whether or not there is a scratch, dent, or other defect in the product. This is called visual inspection, and is helping manufacturers reduce or prevent defects in their products. In all of these applications, you would first train your model with examples of inputs X and the right answers, that is, the labels Y. After the model has learned from these input-output, or X and Y pairs, it can then take a brand new input X, something it's never seen before, and try to produce the appropriate corresponding output Y. Let's dive more deeply into one specific example. Say you want to predict housing prices based on the size of a house. You've collected some data and say you plot the data and it looks like this. Here on the horizontal axis is the size of the house in square feet. And yes, I live in the United States where we still use square feet. I know most of the world uses square meters. And here on the vertical axis is the price of the house in, say, thousands of dollars. So with this data, let's say a friend wants to know what's the price for their 750 square foot house. How can a learning algorithm help you? One thing a learning algorithm might be able to do is say, fit a straight line to the data. And reading off the straight line, it looks like your friend's house could be sold for maybe about, I don't know, $150,000. But fitting a straight line isn't the only learning algorithm you can use. There are others that could work better for this application. For example, rather than fitting a straight line, you might decide that it's better to fit a curve, a function that's slightly more complicated or more complex than a straight line. If you do that and make a prediction here, then it looks like, well, your friend's house could be sold for closer to $200,000. One of the things you see later in this class is how you can decide whether to fit a straight line, a curve, or another function that is even more complex to the data. Now, it doesn't seem appropriate to pick the one that gives your friend the best price. But one thing you see is how to get an algorithm to systematically choose the most appropriate line or other thing to fit to this data. What you see in this slide is an example of supervised learning. Because we gave the algorithm a data set in which the so-called right answer, that is, the label or the correct price Y, is given for every house on the plot. And the task of the learning algorithm is to produce more of these right answers, specifically predicting what is the likely price for other houses like your friend's house. That's why this is supervised learning. To define a little bit more terminology, this housing price prediction is a particular type of supervised learning called regression. And by regression, I mean we're trying to predict a number from infinitely many possible numbers, such as the house prices in our example, which could be 150,000 or 70,000 or 183,000 or any other number in between. So that's supervised learning, learning input, output, or X to Y mappings. And you saw in this video an example of regression, where the task is to predict a number. But there's also a second major type of supervised learning problem called classification. Let's take a look at what that means in the next video.
Bueno, vamos a seguir. Sí, Adrián, no te escucho. Aprendizaje supervisado, parte 2. Bueno, ahí tuve una consulta de Adriano y no hay problema. Si me decís la consulta, trataré. ¿Por qué comparo una regresión lineal con una regresión polinomial? Bueno, porque puede haber unos casos en los cuales un algoritmo se ajuste mejor a los datos que otro. Y entonces, bueno, estamos hablando todavía muy en general, presentando el tema, pero la realidad es que vos después vas a ver si es más apropiado uno u otro en función de los resultados que tengas según las métricas de evaluación que pongas, ¿sí, Adriano? Bueno, seguimos con la segunda parte de aprendizaje supervisado.
So, supervised learning algorithms learn to predict input-output or X to Y mappings. And in the last video, you saw that regression algorithms which is a type of supervised learning algorithm, learns to predict numbers out of infinitely many possible numbers. There's a second major type of supervised learning algorithm called a classification. Now, let's take a look at what this means. Take REST transfer detection as an example of a classification problem. Say you're building a machine learning system so that doctors can have a diagnostic tool to detect breast cancer. This is important because early detection could potentially save a patient's life. Using a patient's medical records, your machine learning system tries to figure out if a tumor, that is a lump, is malignant, meaning cancerous or dangerous, or if that tumor, that lump, is benign, meaning that, it's just a lump that isn't cancerous and isn't that dangerous. Some of my friends have actually been working on this specific problem. So maybe your dataset has tumors of various sizes, and these tumors are labeled as either benign, which I will designate in this example with a 0, or malignant, which I'll designate in this example with a 1. You can then plot your data on a graph like this, where the horizontal axis represents the size of the tumor, and the vertical axis takes on only two values, 0 or 1, depending on whether the tumor is benign, 0, or malignant, 1. One reason that this is different from regression is that we're trying to predict only a small number of possible outputs or categories. In this case, two possible outputs, 0 or 1, benign or malignant. This is different from regression, which tries to predict any number out of the infinitely many number of possible numbers. And so the fact that there are only two possible outputs is what makes this classification. Because there are only two possible outputs or two possible categories in this example, you can also plot this data set on a line like this, where now I'm going to use two different symbols to denote the category, using a circle or an O to denote the benign examples and a cross to denote the malignant examples. And if a new patient walks in for a diagnosis and they have a lump that is this size, then the question is, will your system classify this tumor as benign or malignant? It turns out that in classification problems, you can also have more than 2 possible output categories. Maybe your learning algorithm can output multiple types of cancer diagnoses if it turns out to be malignant. So let's call 2 different types of cancer type 1 and type 2. In this case, the algorithm would have 3 possible output categories it could predict. And by the way, in classification, the terms output classes and output categories are often used interchangeably. So when I say class or category when referring to the output, it means the same thing. So to summarize, classification algorithms predict categories. Categories don't have to be numbers. It could be non-numeric. For example, it can predict whether a picture is that of a cat or a dog, and it can predict if a tumor is benign or malignant. Categories can also be numbers like 0 or 1, or 0 or 1 or 2. But what makes classification different from regression when you're interpreting the numbers is that classification predicts a small, finite, limited set of possible output categories, such as 0, 1, and 2, but not all possible numbers in between, like 0.5 or 1.7. In the example of supervised learning that we've been looking at, we had only one input value, the size of the tumor. But you can also use more than one input value to predict an output. Here's an example. Instead of just knowing the tumor size, say you also have each patient's age in years. Your new dataset now has 2 inputs, age and tumor size. Plotting this new dataset, we're going to use circles to show patients whose tumors are benign, and crosses to show the patients with a tumor that was malignant. So when a new patient comes in, the doctor can measure the patient's tumor size and also record the patient's age. And so given this, how can we predict if this patient's tumor is benign or malignant? Well, given a dataset like this, what the learning algorithm might do is find some boundary that separates out the malignant tumors from the benign ones. So the learning algorithm has to decide how to fit a boundary line to this data. The boundary line found by the learning algorithm would help the doctor with the diagnosis. In this case, the tumor is more likely to be benign. From this example, we've seen how 2 inputs, the patient's age and tumor size, can be used. In other machine learning problems, often many more input values are required. My friends who worked on breast cancer detection used many additional inputs, like the thickness of the tumor clump, uniformity of the cell size, uniformity of the cell shape, and so on. So, to recap, supervised learning maps input X to output Y, where the learning algorithm learns from the, quote, right answers. The 2 major types of supervised learning are regression and classification. In a regression application, like predicting prices of houses, the learning algorithm has to predict numbers from infinitely many possible output numbers. Whereas in classification, the learning algorithm has to make a prediction of a category out of a small set of possible outputs. So you now know what is supervised learning, including both regression and classification. I hope you're having fun. Next, there's a second major type of machine learning called unsupervised learning. Let's go on to the next video to see what that is. So,
Bueno, ¿dónde estábamos? Bueno, ahora viene aprendizaje no supervisado. ¿Sí? Tenemos parte 1 y parte 2, que es lo que vamos a ver ahora.
After supervised learning, the most widely used form of machine learning is unsupervised learning. Let's take a look at what that means. We've talked about supervised learning, and this video is about unsupervised learning. But don't let the name unsupervised fool you. Unsupervised learning is, I think, just as super as supervised learning. When we're looking at supervised learning in the last video, recall that it looks something like this. In the case of a classification problem, each example was associated with an output label Y, such as benign or malignant, designated by the O's and crosses. In unsupervised learning, we're given data that isn't associated with any output labels Y. Say we're given data on patients and their tumor size and patient's age, but not whether the tumor was benign or malignant. So the dataset looks like this on the right. We're not asked to diagnose whether the tumor is benign or malignant because we're not given any labels Y in the dataset. Instead, our job is to find some structure or some pattern or just find something interesting in the data. This is unsupervised learning. We call it unsupervised because we're not trying to supervise the algorithm to give some quote right answer for every input. Instead, we ask the algorithm to figure out all by itself what's interesting or what patterns or structures there might be in this data. With this particular data set, an unsupervised learning algorithm might decide that the data can be assigned to two different groups or two different clusters. And so it might decide that there's one cluster or group over here, and there's another cluster or group over here. This is a particular type of unsupervised learning called a clustering algorithm because it places the unlabeled data into different clusters. And this turns out to be used in many applications. For example, clustering is used in Google News. What Google News does is every day it goes and looks at hundreds of thousands of news articles on the internet and groups related stories together. For example, here's a sample from Google News where the headline of the top article is "Giant Panda Gives Birth to Rare Twin Cubs at Japan's Oldest Zoo." This article had actually caught my eye because my daughter loves pandas, and so there are a lot of stuffed panda toys and watching of panda videos in my house. And looking at this, you might notice that below this are other related articles. Maybe from the headlines alone, you can start to guess what clustering might be doing. Notice that the word panda appears here, 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 and here. And notice that the word twin also appears in all 5 articles. And the word zoo also appears in all of these articles. So the clustering algorithm is finding articles out of all the hundreds of thousands of news articles on the internet that day, finding the articles that mention similar words and grouping them into clusters. Now, what's cool is that this clustering algorithm figures out on its own which words suggest that certain articles are in the same group. What I mean is there isn't an employee at Google News who's telling the algorithm to find articles that have the word panda and twins and zoo to put them into the same cluster. The news topics change every day, and there are so many news stories, it just isn't feasible to have people doing this every single day for all the topics the news covers. Instead, the algorithm has to figure out on its own, without supervision, what are the clusters of news articles today. So that's why this clustering algorithm is a type of unsupervised learning algorithm. Let's look at a second example of unsupervised learning applied to clustering genetic or DNA data. This image shows a picture of DNA microarray data. These look like tiny grids of a spreadsheet, and each tiny column represents the genetic or DNA activity of one person. So, for example, this entire column here is from one person's DNA, and this other column is of another person. Each row represents a particular gene. So just as an example, perhaps this row here might represent a gene that affects eye color, or this row here is a gene that affects how tall someone is. Researchers have even found a genetic link to whether someone dislikes certain vegetables, such as broccoli, Brussels sprouts, or asparagus. So next time someone asks you, why didn't you finish your salad? You can tell them, oh, maybe it's genetic. For DNA microarrays, the idea is to measure how much certain genes are expressed for each individual person. So these colors, red, green, gray, and so on, show the degree to which different individuals do or do not have a specific gene active. And what you can do is then run a clustering algorithm to group individuals into different categories or different types of people. Like maybe these individuals are grouped together, and let's just call this type 1. And these people are grouped into type 2. And these people are grouped as type 3. This is unsupervised learning because we're not telling the algorithm in advance that there is a type 1 person with certain characteristics or a type 2 person with certain characteristics. Instead, what we're saying is, here's a bunch of data. I don't know what the different types of people are, but can you automatically find structure into data and automatically figure out what are the major types of individuals? Since we're not giving the algorithm the right answer for the examples in advance, this is unsupervised learning. Here's a third example. Many companies have huge databases of customer information. Given this data, can you automatically group your customers into different market segments so that you can more efficiently serve your customers? Concretely, the DeepLearning.AI team did some research to better understand the DeepLearning.AI community and why different individuals take these classes, subscribe to the Batch weekly newsletter, or attend our Pioneer events. Let's visualize the DeepLearning.AI community as this collection of people. Running clustering, that is market segmentation, found a few distinct groups of individuals. One group's primary motivation is seeking knowledge to grow their skills. Perhaps this is you, and if so, that's great. A second group's primary motivation is looking for a way to develop their career. Maybe you want to get a promotion or a new job or make some career progression. If this describes you, that's great too. And yet another group wants to stay updated on how AI impacts their field of work. Perhaps this is you. That's great too. This is a clustering that our team used to try to better serve our community as we're trying to figure out what are the major categories of learners in the DeepLearning.AI community. So if any of these is your top motivation for learning, that's great, and I hope I'll be able to help you on your journey. Or in case this is you, and you want something totally different than the other three categories, that's fine too, and I want you to know I love you all the same. So to summarize, a clustering algorithm, which is a type of unsupervised learning algorithm, takes data without labels and tries to automatically group them into clusters. And so maybe the next time you see or think of a panda, maybe you think of clustering as well. And besides clustering, there are other types of unsupervised learning as well. Let's go on to the next video to take a look at some other types of unsupervised learning algorithms.
Bueno, para terminar esta segunda parte, creo que nos queda un video.
After supervised learning,
pasamos a la práctica, ¿sí? Yo lo que les quiero comentar es que es notable, y me imagino que acá hay gente que ya ha hecho cursos con Andrew, lo que ha mejorado Andrew, lo que se ha esforzado para que este curso sea bien básico, bien didáctico, bien claro, ¿no? Porque es un tipo que sabe muchísimo y le encanta explicar, pero a veces, digamos, empieza a hablar y te perdés. No sé si a alguno le pasó. Pero realmente este curso está espectacular, ¿no? Realmente es realmente para disfrutarlo este curso. Es el curso que todos hubiéramos querido hacer cuando empezamos con Machine Learning. No sé si alguien se siente identificado con lo que digo. Bien. Vamos con aprendizaje no supervisado, parte 2. ¿Ya? Después hablamos de la charla Jupyter.
In the last video, you saw what is unsupervised learning and one type of unsupervised learning called clustering. Let's give a slightly more formal definition of unsupervised learning and take a quick look at some other types of unsupervised learning other than clustering. Whereas in supervised learning, the data comes with both inputs X and output labels Y, in unsupervised learning, the data comes only with inputs X but not output labels Y, and the algorithm has defined some structure or some pattern or something interesting in the data. We've seen just one example of unsupervised learning called a clustering algorithm, which groups similar data points together. In this specialization, you learn about clustering as well as two other types of unsupervised learning. One is called anomaly detection, which is used to detect unusual events. This turns out to be really important for fraud detection in the financial system, where unusual events, unusual transactions could be a sign of fraud, and for many other applications. And you also learn about dimensionality reduction. This lets you take a big data set and almost magically compress it to a much smaller data set while losing as little information as possible. In case anomaly detection and dimensionality reduction don't seem to make too much sense to you yet, don't worry about it. We'll get to this later in this specialization. Now, I'd like to ask you another question to help you check your understanding. And no pressure, if you don't get it right on the first try, it's totally fine. Please select
A ver.
In the last video, you saw what are supervised learning examples. So please take a look.
Esto está ya resuelto. Qué bacana. Esperen, a ver. ¿Por qué pasó eso? Bueno, tenemos 4 opciones. A ver. Dice, dado los emails etiquetados como spam y no spam. La pregunta es si es un caso de aprendizaje no supervisado. Aprender un filtro de spam. Otra tienen, dado un conjunto de artículos encontrados en la web, agruparlos en conjunto de artículos sobre la misma historia. Dado una base de datos de clientes, automáticamente descubrir segmentos de mercado y grupos de clientes en diferentes segmentos de mercado. Dado un dataset de pacientes diagnosticados como teniendo diabetes o no, aprender a clasificar nuevos pacientes teniendo diabetes o no. ¿Cuáles serían de estos los casos de aprendizaje no supervisado? No, sí, sí, no. O sea, el segundo, el de los artículos, y el tercero. Esos serían no supervisados. ¿Están todos de acuerdo? Ahí lo propone Federico. Exacto. Bueno, supongo que sí, ¿no? A ver.
So please take a look.
Claro, los artículos y la base de datos de los clientes. Muy bien. Después tengo que ver por qué me pasó esto. Yo pensé que no tenía acá contestado. Qué bacana. Bueno, seguimos. Entonces ahora seguimos por acá.
Any of the following that you think are examples of unsupervised learning. 2 are unsupervised examples and 2 are supervised learning examples. So please take a look. Maybe you remember the spam filtering problem. If you have labeled data, labeled as spam or non-spam email, you can treat this as a supervised learning problem. The second example, the news story example, that's exactly the Google News and Panda example that we saw in the last video. And so you can approach that using a clustering algorithm to group news articles together. So that would use unsupervised learning. The market segmentation example that I talked about a little bit earlier, you can do that as an unsupervised learning problem as well, because you can give your algorithm some data and ask it to discover market segments automatically. And the final example on diagnosing diabetes. Well, actually, that's a lot like our breast cancer example from the supervised learning videos. Only instead of benign or malignant tumors, we instead have diabetes or not diabetes. And so you can approach this as a supervised learning problem, just like we did for the breast tumor classification problem. Even though in this and the last video, we've talked mainly about clustering, in later videos in this specialization, we'll dive much more deeply into anomaly detection and dimensionality reduction as well. So that's unsupervised learning. Before we wrap up this section, I want to share with you something that I find really exciting and useful, which is the use of Jupyter notebooks in machine learning. Let's take a look at that in the next video.
Bueno, vamos a empezar a hablar un poquito de herramientas, de qué herramientas utilizamos.
In the last video,
Se trabaja muchísimo con el lenguaje Python, por eso nosotros en el Centro de Graduados tenemos varios cursos de Python. Y esta herramienta, Jupyter Notebook, se usa mucho. La recomendación, nosotros hemos dado varios talleres de instalación y vamos a seguir dando. La recomendación es que instalen Anaconda, ¿sí? Que instalen Anaconda, que ya viene con un montón de bibliotecas preinstaladas. Y dentro de Anaconda está el paquete Jupyter Notebook. Es indistinto, acá me preguntan, usar Jupyter Notebook o Google Colab. A veces conviene tenerlo local, es un tema de gusto, pero en Colab lo que tiene es que se simplifica mucho el tema de las instalaciones, porque ya está todo y además se comparten mucho. Pero básicamente el Colab es la Jupyter Notebook en Drive de Google. Así que no hay una diferencia esencial, ¿sí? Pueden usar las dos, recomiendo usar las dos. Para algunas cosas, bueno, está bueno tenerla local, no sé, me parece que no hace falta estar trabajando en un Drive, pero las dos se usan mucho. Vamos con Jupyter Notebook.
So far in the videos, you've seen supervised learning and unsupervised learning, and also examples of both. For you to more deeply understand these concepts, I'd like to invite you in this class to see, run, and maybe later write code yourself to implement these concepts. The most widely used tool by machine learning and data science practitioners today is the Jupyter Notebook. This is the default environment that a lot of us use to code up and experiment and try things out. And so in this class, right here in your web browser, you'll be able to use a Jupyter Notebook environment to test out some of these ideas for yourself as well. This is not some made up, simplified, environment. This is the exact same environment, the exact same tool, the Jupyter Notebook that developers are using in many large companies right now. One type of lab that you see throughout this class are optional labs, which are ones you can open and run one line at a time with usually not needing to write any code yourself. So optional labs are designed to be very easy, and I can guarantee you will get full marks for every single one of them because there are no marks. All you need to do is open it up and just run the code provided. And I even through and run the code on the optional labs, you see how machine learning code runs. And you should be able to complete them, relatively quickly, just by running it one line at a time from top to bottom. Optional labs are completely optional, so you don't have to do them at all if you don't want to. But I hope you will take a look, because running through them will give you a deeper feel, give you a little bit more experience with what machine learning algorithms, what machine learning code actually looks like. Starting next week, there'll also be some practice labs, which will give you an opportunity to write some of that code yourself. But we'll get to that next week, so don't worry about it for now. And I hope you just go through the next optional lab and get through the rest of the content for this week. So let's take a look at an example of a notebook. Here's what you see when you go to the first optional lab. Feel free to scroll up and down and browse and mouse over the different menus and take a look at the different options here. You might notice that there are two types of these blocks, also called cells, in the notebook. And there are two types of cells. One is what's called a markdown cell, which means basically a bunch of text. So here you can actually edit the text if you don't like the text that we wrote. But this is text that describes the code. Then there's a second type of block or cell, which looks like this, which is a code cell. So here we've already provided the code, and if you want to run this code cell, hitting Shift-Enter will run the code in this code cell. Oh, and by the way, if you click on the Markdown cell, so this is showing all this formatting, go ahead and hit Shift-Enter on your keyboard as well, and that will also convert it back to this nicely formatted text. This optional lab shows some common Python code, so you can go ahead and run this afterwards in your own Jupyter notebook. When you jump into this notebook yourself, what I'd like you to do is select the cells and hit Shift-Enter. Well, read through the code, see if it makes sense. Try to make a prediction about what you think this code will do, and then hit Shift-Enter. And then see what the code actually does. And if you feel like it, feel free to go in and edit the code. Change the code and then run it and see what happens. And if you haven't played in a Jupyter Notebook environment before, I hope you become more familiar with Python in a Jupyter Notebook. I spend a lot of hours playing around in Jupyter Notebooks, and so I hope you have fun with them too. And after that, I look forward to seeing you in the next video, where we'll take the supervised learning problem and start to flesh out our first supervised learning algorithm. I hope that'll be fun too, and look forward to seeing you there.
Bueno, y ahora viene un laboratorio que en realidad no son ejercicios, sino que ya están hechos, están buenos. No sé si acá Carla y Emiliano los bajaron o no. Ah, sí, mira, acá está la quiz. A ver.
Pero esa está resuelta.
No, pará. Preguntas, video. No está. Ah, bueno. Bueno, vamos a hacerlo. A ver. Vamos a abrir el laboratorio. Esto también está muy bueno de Coursera, que tiene los ejercicios online.
También tenés quiz para esta sección.
Ah, sí, a ver. Ah, acá viene después una quiz. Bueno, bárbaro. Gracias, Carla. Bueno, laboratorio opcional. Una breve introducción a Python y a la Jupyter Notebook. Bien. Entonces, básicamente, ven que tenemos lo que puede ser. Cada bloquecito puede ser de código o de Markdown, que vendría a ser un entorno enriquecido. ¿Sí? Que de Markdown también se usa en Git, se usa, por ejemplo, en WhatsApp. Si ustedes ponen asterisco, que le ponen negrita, eso es Markdown. Este es fíjese, ok, acá es código. Si le pongo Markdown, esto no va a andar, es cualquier cosa. No va a hacer cualquier cosa. Ahora vamos a ponerle código. Dice, esto es una celda de código. Si vas a la carpeta semana 1, ahí está la carpeta, buenísimo. Semana 1. A ver, acá, semana 1. Acá tienen laboratorios. Qué bueno. Bueno, genial, ¿no? La útil. Mirá, bajaron todo. Bueno, eso está todo disponible. Bueno, agradezcanle acá a los compañeros, Emiliano y Carla, que trabajaron esto. Bueno, buenísimo. Bueno, vamos a ejecutar, entonces ejecutamos acá. Dice, imprime. Esto es una celda de código, ¿sí? Bueno. Le pones Shift Enter o directamente Run acá. Con el print, entonces, ¿qué hace el print? Pones entre paréntesis un texto y te lo imprime. Y acá está con un formato, ven que acá pone variable, entre llaves, y te lo formatea, ¿sí? F-string te permite ver variables en los strings. Esto se llama, bueno, Es una forma de Python de escribir con formato. Se usa mucho en los logs, ¿sí? Cuando uno quiere escribir un log, lo usamos mucho en el curso que estamos haciendo los sábados a la mañana con Emiliano de Google IT Automation. Bueno, terminamos, no, falta como dice Carla, bien, un cuestionario. Vamos a ver el cuestionario. Dice, ¿cuáles son los dos tipos más comunes de aprendizaje supervisado? Dice, clasificación, regresión, clustering. ¿Qué dicen ustedes? A y B, dice Adriano. ¿Están todos de acuerdo? 1 y 2, dice Mauri. Bueno. ¿Cuáles son los tipos de aprendizaje no supervisado? Clustering, clasificación, regresión. ¿O cuál de estos es un tipo de aprendizaje no supervisado? Clustering, ¿no? Bueno. Bueno, yo siempre hago el mismo chiste. Fíjense que Andrew está reclutando, ¿eh? Si nos llega a ver, ahí un headhunter, a ver qué resultado da. 100%, por eso digo, tengan cuidado, vayan preparando la Pioneer, la cuenta Pioneer para cobrar en dólares. Bueno, antes de seguir la siguiente sección, vamos a volver a pasar el link al grupo de WhatsApp. La idea es que ustedes se sumen ahí y den el presente poniendo su nombre y apellido, si son tan amables. Ahí se los paso. Y se lo paso también a los muchachos de YouTube. Ahí les paso el grupo de WhatsApp. Y les voy a pasar también un link para suscripciones. Si se quieren suscribir, ya mismo. O sea, si ustedes pagan ahora por Mercado Pago, ya les damos acceso a los 10.000 cursos en Coursera. Donde está incluido que es el de... No era ¿no? Suscripción. No, suscripción. Ahí está. Son 3.000 pesitos argentinos y tienen los 10.000 cursos. Ahí les paso el link. No sé cuánto tiempo se va a mantener este precio porque en Argentina hay una inflación galopante, pero bueno, por ahora lo estamos manteniendo. Ahí se los paso, si alguno quiere. Creo que acá hay varios usuarios de Coursera en este grupo. Está Carla, está Mariela Cirur. Perdón si me olvido de alguien, ¿no? Hay unos cuantos. No sé si alguien quiere comentar. Creo que en general están bastante satisfechos. Pero... Bueno, seguimos entonces. Ahí viene. Vamos a ver entonces el modelo de regresión, ¿sí? Vamos a ver, tenemos unos videitos. Supongo que en un rato haremos un pequeño corte. Ahí está previsto 3 horas, no sé si llegamos. Así que bueno, si ustedes quieren aguantamos, pero estaría bueno poder terminar la primera semana hoy. Es medio larguita. Vamos entonces con regresión lineal, modelo de regresión lineal, parte 1. Ahí va.
In this video, we'll look at what the overall process of supervised learning is like. Specifically, you see the first model of this course, a linear regression model. That just means fitting a straight line to your data. It is probably the most widely used learning algorithm in the world today. And as you get familiar with linear regression, many of the concepts you see here will also apply to other machine learning models that you see later in this specialization. Let's start with a problem that you can address using linear regression. Say you want to predict the price of a house based on the size of the house. This is the example we've seen earlier this week. We're going to use the dataset on house sizes and prices from Portland, a city in the United States. Here we have a graph where the horizontal axis is the size of the house in square feet, and the vertical axis is the price of the house in thousands of dollars. Let's go ahead and plot the data points for various houses in the dataset. Here, each data point, each of these little crosses is a house with a size and price that it most recently was sold for. Now, let's say it's a real estate agent in Portland, and I click the client to sell a house. And she tells me, how much do you think you could get for this house? This dataset might help you estimate the price she could get for it. You start by measuring the size of the house, and it turns out that her house is 1,250 square feet. How much do you think this house could sell for? One thing you could do is you can build a linear regression model from this dataset. Your model will fit a straight line to the data, which might look like this. And based on this straight line fit to the data, you can kind of see that if a house is 1,250 square feet, it will intersect the best fit line over here. And if you trace that to the vertical axis on the left, you can see the prices maybe around here, say about $220,000. So this is an example of what's called a supervised learning model. We call this supervised learning because you are first training your model by giving it data that has the right answers. Because you give the model examples of houses with both the size of the house as well as the price that the model should predict for each house. Where here, the prices, that is, the right answers, are given for every house in the dataset. This linear regression model is a particular type of supervised learning model. It's called a regression model because it predicts numbers as the output, like prices in dollars. Any supervised learning model that predicts a number, such as 220,000 or 1.5 or negative 33.2, is addressing what's called a regression problem. So linear regression is one example of a regression model, but there are other models for addressing regression problems too. And we'll see some of those later in course 2 of this specialization. And just to remind you, in contrast with the regression model, the other most common type of supervised learning model is called a classification model. A classification model predicts categories or discrete categories, such as predicting if a picture is of a cat, meow, or a dog, woof. Or if given a medical record, it has to predict if a patient has a particular disease. You see more about classification models later in this course as well. So as a reminder about the difference between classification and regression, in classification, there are only a small number of possible outputs. If your model is recognizing cats versus dogs, that's 2 possible outputs. Or maybe you're trying to recognize any of 10 possible medical conditions in a patient. So there's a discrete, finite set of possible outputs. We call it a classification problem, whereas in regression, there are infinitely many possible numbers that the model could output. In addition to visualizing this data as a plot here on the left, there's one other way of looking at the data that would be useful, and that's a data table here on the right. The data comprises a set of inputs. This would be the size of the house, which is this column here. It also has outputs. You're trying to predict the price, which is this column here. Notice that the horizontal and vertical axes correspond to these 2 columns, the size and the price. And so if you have, say, 47 rows in this data table, then there are 47 of these little crosses on the plot of the left, each cross corresponding to 1 row of the table. For example, the first row of the table is a house with size 2,104 square feet, so that's around here. And this house sold for $400,000. dollars, which is around here. So this first row of the table is displayed as this data point over here. Now, let's look at some notation for describing the data. This is notation that you find useful throughout your journey in machine learning. As you increasingly get familiar with machine learning terminology, this will be terminology that you can use to talk about machine learning concepts with others as well, since a lot of this is quite standard across AI. You'll be seeing this notation multiple times in the specialization, so it's okay if you don't remember everything the first time through. It will naturally become more familiar over time. The data set that you just saw and that is used to train the model is called a training set. Note that your client's house is not in this data set because it's not yet sold, so no one knows what its price is. So to predict the price of your client's house, you first train your model to learn from the training set, and that model can then predict your client's house's price. In machine learning, the standard notation to denote the input here is lowercase x, and we call this the input variable. It's also called a feature or an input feature. For example, for the first house in your training set, x is the size of the house, so x equals 2,104. The standard notation to denote the output variable, which you're trying to predict, which is also sometimes called the target variable, is lowercase y. And so here, y is the price of the house, and for the first training example, this is equal to 400. So y equals 400. So the data set has one row for each house, and in this particular training set, there are 47 rows, with each row representing a different training example. We're going to use lowercase m to refer to the total number of training examples, and so here, m is equal to 47. To indicate a single training example, we're going to use the notation parentheses x comma y. So for the first training example, x comma y, this pair of numbers is 2,104, comma 400. Now, we have a lot of different training examples. We have 47 of them, in fact. So to refer to a specific training example, this will correspond to a specific row in this table on the left. I'm going to use the notation x superscript in parentheses I, comma, y superscript in parentheses I. The superscript tells us that this is the ith training example, such as the first, second, or third up to the 47th training example. I here refers to a specific row in the table. So, for instance, here is the first example when I equals 1 in the training set. And so x superscript 1 is equal to 2,104, and y superscript 1 is equal to 400. And let's add the superscript 1 here as well. Just a note, this superscript I in parentheses is not exponentiation. So when I write this is not x squared. This is not x to the power of 2. It just refers to the second training example. So this I is just an index in the training set and refers to row I in the table. In this video, you saw what a training set is like, as well as the standard notation describing this training set. In the next video, let's look at what it'll take to take this training set you just saw and feed it to a learning algorithm so that the algorithm can learn from this data. Let's see that in the next video.
Bueno, vamos a seguir, veo algunas dudas, ahí voy a aclarar algunas cositas que viene ahora, la parte 2, ¿no? modelo de regresión lineal, parte 2, que sería acá. Perfecto. Sí, algunas preguntas que veo. Sí, los planes que le estamos pasando es en peso argentino. La verdad que para la gente de afuera, lo que yo les recomiendo, lo pueden pagar vía PayPal. Con $33 les incluye todo, ¿sí? O sea, el plan oro tiene todos nuestros cursos con docente, ¿sí? Entonces yo les recomiendo directamente que vayan a ese plan. Si ustedes pagan en pesos argentinos, el problema es que le van a hacer el cambio al valor oficial del dólar, que es más o menos la mitad de lo que vale el dólar en el mercado, digamos. Entonces, para nosotros 3.000 pesos, para Argentina hoy son más o menos $10. Y a usted le va a salir 20 y pico. Entonces, lo que les recomiendo es directamente que contraten por PayPal, lo pagan vía PayPal en dólares, son $33, que para Argentina es un montón de plata, y para afuera realmente es bastante accesible. Eso no sé si... la diferencia por eso, el plan plata le da acceso a Coursera, son los 10.000 cursos de Coursera. Y el plan oro, además de Coursera, tiene el acceso a nuestros cursos con docente, con tutor, que estamos dando un montón de cursos. Igual tienen todo, hay una web, graduadosfiuba.org, graduadosfiuba.org. La voy a pasar también por YouTube. Ahí va. Y tienen también una web que se llama, la acaba de pasar recién, ya.tuexitoprofesional.uru. No está completa la web, pero ahí están todos los próximos cursos que vamos a dar. También hay una oferta por un pago único en dólares y tienen acceso a todos esos 11 cursos que están empezando ahora, y también levantar todo el año que viene el acceso a Coursera. O sea que también les conviene un montón. Creo que son $249. Ahí les paso. Esta es una oferta que tenemos ahora de la pretemporada 2023. Lo paso también por YouTube. Bueno, pero igual cualquier cosa, consultan con la gente del equipo de coordinación. Ahí en el grupo de WhatsApp está Emiliano y está Yasmin. Bueno, seguimos. Modelo de regresión lineal, parte 2. Ah, por WhatsApp. Bueno, ahora paso todo por WhatsApp. Bueno, pero en WhatsApp estamos, después de que termine la call. ¿Qué tal, Walter? Bueno, che, nos tenemos que ver, Walter. Walter, perdón. Vamos a abrir una oficina ahora en el centro, así que tenemos que charlar. Bueno, vamos a ver.
Let's look in this video at the process of how supervised learning works. Supervised learning algorithm will input a data set, and then what exactly does it do and what does it output? Let's find out in this video. Recall that a training set in supervised learning includes both the input features, such as the size of the house, and also the output targets, such as the price of the house. The output targets are the right answers that the model will learn from. To train the model, you feed the training set both the input features and the output targets to your learning algorithm. Then your supervised learning algorithm will produce some function. We'll write this function as lowercase f, where f stands for function. Historically, this function is used to call a hypothesis, but I'm just going to call a function f in this class. And the job of f is to take a new input x and output an estimate or prediction, which I'm going to call y hat. And it's written like the variable y with this little hat symbol on top. In machine learning, the convention is that y hat is the estimate or the prediction for y. The function f is called the model. X is called the input or the input feature, and the output of the model is the prediction y hat. The model's prediction is the estimated value of y. When the symbol is just the letter y, then that refers to the target, which is the actual true value in the training set. In contrast, y hat is an estimate. It may or may not be the actual true value. Well, if you're helping your client to sell their hulls, well, the true price of the hulls is unknown until they sell it. So your model F, given the size, outputs a price which is the estimated, that is the prediction of what the true price will be. Now, when we design a learning algorithm, a key question is, how are we going to represent the function f? Or in other words, what is the math formula we're going to use to compute f? For now, let's stick with f being a straight line. So your function can be written as f subscript w comma b of x equals, I'm going to use w times x plus b. I'll define w and b soon, but for now, just know that w and b are numbers, and the values chosen for w and b will determine the prediction y hat based on the input feature x. So this fwb of x means f is a function that takes x as input, and depending on the values of w and b, f will output some value of a prediction y hat. As an alternative to writing this fw comma b of x, I'll sometimes just write f of x without explicitly including w and b in the subscript. It's just a simpler notation, but means exactly the same thing as fwb of x. Let's plot the training set on the graph where the input feature x is on the horizontal axis and the output target y is on the vertical axis. Remember, the algorithm learns from this data and generates a best fit line, like maybe this one here. This straight line is the linear function fwb of x equals w times x plus b. Or more simply, we can drop w and b and just write f of x equals wx plus b. Here's what this function is doing. It's making predictions for the value of y using a straight line function of x. So you may ask, why are we choosing a linear function where linear function is just a fancy term for a straight line instead of some nonlinear function like a curve or a parabola? Well, sometimes you want to fit more complex nonlinear functions as well, like a curve like this. But since this linear function is relatively simple and easy to work with, let's use a line as a foundation that will eventually help you to get to more complex models that are nonlinear. This particular model has a name. It's called linear regression. More specifically, this is linear regression with one variable, where the phrase one variable means that there's a single input variable or feature x, namely the size of the house. And another name for a linear model with one input variable is univariate linear regression, where uni means one in Latin, and where variate means variable. So univariate is just a fancy way of saying one variable. In a later video, you also see a variation of regression where you want to make a prediction based not just on the size of the house, but on a bunch of other things that you may know about the house, such as the number of bedrooms and other features. And by the way, when you're done with this video, there is another optional lab. You don't need to write any code. Just review it, run the code, and see what it does. That will show you how to define in Python a straight line function. And the lab will let you choose the values of w and b to try to fit the training data. You don't have to do the lab if you don't want to, but I hope you play with it when you're done watching this video. So that's linear regression. In order for you to make this work, one of the most important things you have to do is construct a cost function. The idea of a cost function is one of the most universal and important ideas in machine learning, and is used in both linear regression and in training many of the most advanced AI models in the world. So let's go on to the next video and take a look at how you can construct a cost function.
Bueno, vamos a ver el ejercicio que hay, la práctica supervisada.
Let's look in this video.
Avísenme, ¿no? Porque ya se pasó la hora y media, si quieren cortar un ratito, porque son temas densos, ¿eh? Bueno, vamos a ver este laboratorio. En general, a la tarde, los sábados hacíamos de 14 a 18. Pero la verdad que di clase a la mañana y no estoy llegando. Pero tendríamos que haber empezado a las 14. Bueno, entonces acá vamos a representar el modelo, ¿sí? Vamos a tratar de implementar el modelo que es una función de W y B, ¿no? La pendiente y la término independiente. Y bueno, acá tienen. A es un escalar, este es un vector que está en negrita, regresión, X, ejemplo de entrenamiento, este es el target, el objetivo, digamos, el resultado. X, el par X, Y es un ejemplo de entrenamiento, M es el número de ejemplo de entrenamiento, W el parámetro que es un peso, y este es el bias, ¿no? El término independiente. F que depende de W y B de X de Y, es el resultado de la evaluación del modelo en X y con los parámetros W y B, ¿no? Entonces F y W de X y es WXY más B. Bueno, vamos a usar entonces la biblioteca que importamos NumPy, le ponemos un alias como NP para escribir menos, importamos la biblioteca matplotlib.pyplot, que es una biblioteca gráfica, NumPy es numérica, y traemos este estilo, ¿no? Que se ve que es algo que armaron ellos. Entonces, básicamente vamos a usar este ejemplo de las casas, ¿no? Estos ejercicios están muy lindos porque es como que vuelve a dar la teórica. Así que uno lo lee y... Bueno, entonces básicamente generamos un vector, digamos, de ejemplo de entrenamiento, que son dos valores, los targets, los mostramos, siempre ahí con el formato que habíamos visto antes. Bueno, vamos a usar f-string, la salida de f-string. ¿Sí? Acá hay una ayudita también, una documentación. Bueno, el número de ejemplo de entrenamiento, vamos a usar m para hacer el número, y fíjense que el vector x va a tener, si yo le pido el shape, o sea, la forma, me va a volver una tupla. Va a volver los valores del cual el primer valor de la tupla va a ser la cantidad de ejemplos de entrenamiento. ¿Sí? Por eso le ponemos x3.shape0, que es la cantidad de ejemplos de entrenamiento. Fíjense que si yo le saco esto, el shape, ahí me devuelve la tupla. Porque ya sé. Vamos a hacer así. Print. Print. X3 shape. Ven que me devuelve, bueno, 2 y nada, ¿sí? Pero acá en este nada iría la dimensión. Me explico que podría ser 10, en este caso es uno solo. Bueno, esto pasa mucho, digamos, de usar este corchete 0 sería agarrar el primer elemento de la forma, o sea, de la tupla. Bueno, o podemos usar, ahí está, tomamos X3, la longitud, también te tiene que dar lo mismo. En este caso son dos ejemplos. Bueno, después entonces vamos a usar X y Y para denotar los ejemplos de entrenamiento. Esto es lo mismo que dijo Andrew. Entonces, bueno, básicamente Y sería el subíndice. Ahí tenemos XY, si le pongo Y igual 1, ahí me va a traer el segundo. Ahí está. El segundo ejemplo. Bueno, esto está bueno para jugar, para ir probando, para ver código. O sea, para los que son nuevos, la recomendación es que practiquen, que miren. Después vamos a plotear los datos con esta PNT. ¿Se acuerdan que era el alias que le dimos a la matplotlib? Y mostramos, bueno, nos vamos el gráfico y ahí nos salvamos. Bueno, en este caso son dos puntitos nomás, ¿no? Y después armamos el modelo. Aquí tienes W y B y calcula. Bueno, hay que mirarlo tranqui, cómo está armado, pero básicamente implementa. Y después había un lugar, no me acuerdo si era acá o no. Ahí está, por ejemplo acá, fíjense que con este W y B es medio malo. Pero yo después puedo ir jugando, experimentar con distintos valores de W y B. Para ir probando a ver si le podemos pegar alguno un poquito mejor. ¿Sí? No, está muy bien armadito, la verdad que está piola esto. Es para dedicarle un tiempito y probar. Bueno, ¿quieren seguir o quieren parar un ratito? Sí, sí, sí. Vamos a parar 10 minutos porque si no se hace muy largo y, y seguimos en 10 minutos. Sí, así paramos un ratito, entonces a las 5 seguimos. Hola, buenas. Bueno, ahí Joaquín Spini se acaba de suscribir, así que le vamos a dar acceso.
Excelente, gracias.
¿Estás ahí, Joaquín?
Sí, por acá estoy.
Bueno. Entonces, a ver,
Muchas gracias.
para que todavía no te di nada. A ver. Acá está, ¿no? Joaquín Spini. Tu mail es joaquín.spini@gmail.com, ¿no?
Sí, exacto.
Muy bien, entonces, no sé si están viendo mi pantalla. Vamos. Esto es así, es un sistema de licencias transferibles. Fíjense, nosotros tenemos, en este momento, tenemos 12 licencias. Y vamos comprando más a medida que se van sumando los suscriptores. Entonces, ¿nosotros qué hacemos? Los borramos y dice eliminar estudiantes, pero dice permite que los alumnos se unan a los programas nuevamente sin necesidad de invitación. La realidad es que uno usa la licencia solamente en el momento que va a rendir el examen. Si no, mira los videos, entonces se puede compartir. Invitar a estudiantes y vos te suscribiste al plan plata, ¿no?
Sí.
Ahí está, continuar. Invita a los estudiantes, bueno, Joaquín Spini y Joaquín Spini. Bueno, ahora te tiene que estar llegando un mail. ¿Vos ya tenés usuario de Coursera con este mail?
No.
Bueno, entonces, anotate en Coursera, registrate, si querés te ayudo, compartir pantalla, o después como vos quieras.
No, después lo hago,
bueno,
no paramos el curso.
Ahí está, bueno, ahí te tiene que llegar el mail, ahí te mandé, y acordate eso, que te vamos a borrar, vos te tenés que inscribir cada vez que entras y tomás licencia, te inscribís al curso, y no se pierde el avance, ¿está bien?
¿Me podés repetir eso como dijiste que me estabas haciendo?
Vos, cada vez que tomás licencia, que entras a Coursera, te va a decir que entres al programa. Así, mira, fíjate cómo voy a hacer yo ahora. Yo voy a entrar acá. Voy a entrar. Y recién yo borré a todos, entonces no estoy usando licencia. Entonces, entro y ves que me da la opción de unirme al programa. Entonces pongo volver al programa.
Y ahí te pregunta a ver si o te evalúa si estás o no inscrito.
No. Tenés que volver a escribir. Así es el sistema. Tengo que poner Machine Learning, hay que volver a inscribirse. Machine Learning, ahí me inscribo. Inscribirse. Ya pongo mis cursos. Ya estoy inscrito. Si no, no me lo toma. Tiene ese truquito. Hay que aprender a usarlo, hay que ponerse cancha.
Vale. Buenísimo, fácil.
Igual ahora te agrego al grupo de Plan Plata y cualquier cosa preguntas ahí. Hay un grupo que hay un montón de compañeros que están en la misma que vos.
Dale, perfecto. No, buenísimo.
Escúchenme, las licencias estas es una suscripción mensual, es una cuota que se paga todos los meses. Mientras ustedes paguen la cuota, van a tener acceso. Me la dejan de pagar, pierden el acceso. Coursera esto lo cobra $60 por mes. Fíjense, Coursera Plus, entren a Coursera Plus y van a ver que lo cobra $60. Así que realmente creo que está muy en precio. Bueno, seguimos. Habíamos llegado a ponerme a cualquier curso y ese curso tengo acceso a todo. Sí, incluido el certificado. Sí, Matías. Sí, correcto. Así es el sistema. ¿Ok? Bueno, vamos con entonces la función de costo. ¿Sí? Vamos a ver qué es la función de costo. Ejemplos, hay un lab. Y después está todo el modelo de regresión y el sistema del descenso del gradiente. Son contenidos ya un poquito más pesaditos. Así que prestando atención. Y si no, bueno, van a tener los videos en el Drive. Porque estas cosas, o sea, hay que masticarlas, ¿no? Son temas, está bien básicos, pero hay que masticarlas, hay que verlos varias veces, hacer los ejercicios, ver distintos temas. Bien, seguimos. Entonces ahora venía función de costo, ¿no? Tú y yo. Cost function formula. Cost function formula.
In order to implement linear regression, The first key step is for us to define something called a cost function. This is something we'll build in this video. And the cost function will tell us how well the model is doing so that we can try to get it to do better. Let's look at what this means. Recall that you have a training set that contains input features X and output targets Y. And the model you're going to use to fit this training set is this linear function f wb of x equals w times x plus b. To introduce a little bit more terminology, the w and b are called the parameters of the model. In machine learning, parameters of the model are variables you just do training in order to improve the model. Sometimes you also hear the parameters w and b referred to as coefficients or as weights. Now, let's take a look at what these parameters w and b do. Depending on the values you've chosen for w and b, you get a different function f of x, which generates a different line on the graph. And remember that we can write f of x as a shorthand for fwb of x. We're going to take a look at some plots of f of x on a chart. Maybe you're already familiar with drawing lines on charts, but even if this is a review for you, I hope this will help you build intuition on how w and b, the parameters, determine f. When w is equal to 0 and b is equal to 1.5, then f looks like this horizontal line. In this case, the function f of x is 0 times x plus 1.5. So f is always a constant value. It always predicts 1.5 for the estimated value of y. So y hat is always equal to b. And here, b is also called the y-intercept because that's where it crosses the vertical axis or the y-axis on this graph. As a second example, if w is 0.5 and b is equal to 0, then f of x is 0.5 times x. When x is 0, the prediction is also 0. And when x is 2, then the prediction is 0.5 times 2, which is 1. So you get a line that looks like this. And notice that the slope is 0.5 divided by 1. So the value of w gives you the slope of the line, which is 0.5. And finally, if w equals 0.5 and b equals 1, then f of x is 0.5 times x plus 1. And when x is 0, then f of x equals b, which is 1. So the line intersects the vertical axis at b, the y-intercept. Also, when x is 2, then f of x is 2. So the line looks like this. Again, the slope is 0.5 divided by 1, so the value of w gives you the slope, which is 0.5. Recall that you have a training set, like the one shown here. With linear regression, what you want to do is to choose values for the parameters w and b, so that the straight line you get from the function f somehow fits the data well, like maybe this line shown here. And when I say that the line fits the data, visually, you can think of this to mean that the line defined by f is roughly passing through or somewhat close to the training examples as compared to other possible lines that are not as close to these points. And just to remind you of some notation, a training example like this point here is defined by x superscript I, y superscript I, where y is the target. For a given input xi, the function f also makes a predicted value for y, and the value that it predicts for y is y hat I, shown here. For our choice of a model, f of xi is w times xi plus b. Stated differently, the prediction y hat I is f of wb of xi, where for the model we're using, f of xi is equal to wxi plus b. So now the question is, how do you find values for w and b so that the prediction y hat I is close to the true target yi for many or maybe all training examples xi, yi? To answer that question, let's first take a look at how to measure how well a line fits the training data. To do that, we're going to construct our cost function. The cost function takes the prediction y hat and compares it to the target y by taking y hat minus y. This difference is called the error. We're measuring how far off the prediction is from the target. Next, let's compute the square of this error. Also, we're going to want to compute this term for different training examples I in the training set. So when measuring the error for example I, we'll compute this squared error term. Finally, we want to measure the error across the entire training set. In particular, let's sum up the squared errors like this. We'll sum from I equals 1, 2, 3, all the way up to m. And remember that m is the number of training examples, which is 47 for this dataset. Notice that if we have more training examples, m is larger, and your cost function will calculate a bigger number since it's summing over more examples. So to build a cost function that doesn't automatically get bigger as the training set size gets larger, by convention, we will compute the average squared error instead of the total squared error, and we do that by dividing by m like this. Okay, we're nearly there. Just one last thing. By convention, the cost function that machine learning people use actually divides by 2 times m. The extra division by 2 is just meant to make some of our later calculations a little bit neater, but the cost function still works whether you include this division by 2 or not. So this expression right here is the cost function, and we're going to write j of wb to refer to the cost function. This is also called the squared error cost function, and it's called this because you're taking the square of these error terms. In machine learning, different people will use different cost functions for different applications, but the squared error cost function is by far the most commonly used one for linear regression, and for that matter, for all regression problems, where it seems to give good results for many applications. So just as a reminder, the prediction y hat is equal to the output of the model f at x. So we can rewrite the cost function j of wb as 1 over 2m times the sum from I equals 1 to m of f of x I minus yi, the quantity squared. Eventually, we're going to want to find values of w and b that make the cost function small. But before going there, let's first gain more intuition about what j of wb is really computing. At this point, you might be thinking, we've done a whole lot of math to define the cost function, but what exactly is it doing? Let's go on to the next video where we'll step through one example of what the cost function is really computing that I hope will help you build intuition about what it means if j of wb is large versus if the cost j is small. Let's go on to the next video.
Bueno, seguimos. Lo que sí lo dejo
In order to implement the
a criterio de ustedes. Nos quedan 4 videos, un lab y un quiz. Y después tenemos entrenando el modelo con descenso del gradiente. Capaz que es un poquito largo, yo no tengo problema, pero me dicen si quieren llegar hasta acá o esto después si quieren lo miran ustedes, eso es al gusto de ustedes. Vamos a terminar con la función de costo que nos va a dar el tiempo, pero seguramente se nos va a ir. Pero yo no tengo drama si hay gente que se quiera quedar a mirarlo, pero bueno, eso lo vamos viendo en función. ¿Qué viene ahora? Viene la intuición, o sea, el concepto de qué es la función de costo.
We've seen the mathematical definition of the cost function. Now, let's build some intuition about what the cost function is really doing. In this video, we'll walk through one example to see how the cost function can be used to find the best parameters for your model. I know this video is a little bit longer than the others, but bear with me, I think it'll be worth it. To recap, here's what we've seen about the cost function so far. You want to fit a straight line to the training data, so you have this model FWB of x is w times x plus b. And here, the model's parameters are w and b. Now, depending on the values chosen for these parameters, you get different straight lines, like this. And you want to find values for w and b so that the straight line fits the training data well. To measure how well a choice of w and b fits the training data, you have a cost function j. And what the cost function j does is it measures the difference between the model's predictions and the actual true values for y. What you see later is that linear regression will try to find values for w and b that make j of w be as small as possible. In math, we write it like this. We want to minimize j as a function of w and b. So now, in order for us to better visualize the cost function j, let's work with a simplified version of the linear regression model. We're going to use the model fw of x is w times x. You can think of this as taking the original model on the left and getting rid of the parameter b, or setting the parameter b equal to 0, so it just goes away from the equation. So f is now just w times x. So you now have just one parameter w, and your cost function j looks similar to what it was before, taking the difference and squaring it, except that now f is equal to w times xi, and j is now a function of just w. And the goal becomes a little bit different as well, because you have just one parameter w, not w and b. So with this simplified model, the goal is to find a value for w that minimizes j of w. To see this visually, what this means is that if b is set to 0, then f defines a line that looks like this. And you see that the line passes through the origin here, because when x is 0, well, f of x is 0 too. Now, using this simplified model, let's see how the cost function changes as you choose different values for the parameter w. In particular, let's look at graphs of the model f of x and the cost function j. I'm going to plot these side by side, and you'll be able to see how the two are related. First, notice that for f subscript w, when the parameter w is fixed, that is always a constant value, then fw is only a function of x, which means that the estimated value of y depends on the value of the input x. In contrast, looking to the right, the cost function j is a function of w, where w controls the slope of the line defined by fw. So the cost defined by j depends on a parameter, in this case, the parameter w. So let's go ahead and plot these functions fw of x and j of w side by side, so that you can see how they are related. We'll start to the model, that is the function fw of x on the left. Here, the input feature x is on the horizontal axis, and the output value y is on the vertical axis. Here's a plot of 3 points representing the training set at positions 1, 1, 2, 2, and 3, 3. Let's pick a value for w. Say w is 1. So for this choice of w, the function fw looks like this straight line, with a slope of 1. Now, what you do is calculate cos j when w equals 1. So you may recall that the cost function is defined as follows. It's the squared error cost function. So if you substitute fw of xi with w times xi, the cost function looks like this, where this expression is now w times xi minus yi. So for this value of w, it turns out that the error term inside the cost function, this w times xi minus yi, is equal to 0 for each of the 3 data points. Because for this data set, when x is 1, then y is 1. When w is also 1, then f of x equals 1. So f of x equals y for this first training example, and the difference is 0. Plugging this into the cost function j, you get 0 squared. Similarly, when x is 2, then y is 2, and f of x is also 2. So again, f of x equals y for the second training example. In the cost function, the squared error for the second example is also 0 squared. Finally, when x is 3, then y is 3, and f of 3 is also 3. In the cost function, the third squared error term is also 0 squared. So for all 3 examples in this training set, f of xi equals yi for each training example I. So f of xi minus yi is 0. So for this particular data set, when w is 1, then the cost j is equal to 0. Now, what you can do on the right is plot the cost function j. And notice that because the cost function is a function of the parameter w, the horizontal axis is now labeled w and not x. And the vertical axis is now j and not y. So you have j of 1 equals to 0. In other words, when w equals 1, j of w is 0. So let me go ahead and plot that. Now let's look at how f and j change for different values of w. W can take on a range of values, right? So w can take on negative values, w can be 0, and it can take on positive values too. So what if w is equal to 0.5 instead of 1? What will these graphs look like then? Let's go ahead and plot that. So let's set w to be equal to 0.5. And in this case, the function f of x now looks like this, is a line with a slope equal to 0.5. And let's also compute the cost j when w is 0.5. Recall that the cost function is measuring the squared error or difference between the estimated value, that is y hat I, which is f of xi, and the true value, that is yi, for each example I. So visually, you can see that the error or difference is equal to the height of this vertical line here when x is equal to 1, because this little line is the gap between the actual value of y and the value that the function f predicted, which is a bit further down here. So for this first example, when x is 1, f of x is 0.5. So the squared error on the first example is 0.5 minus 1 squared. Remember, the cost function will sum over all the training examples in training example. So let's go on to the second training example. When x is 2, the model is predicting f of x is 1, and the actual value of y is 2. So the error for the second example is equal to the height of this little line segment here. And the squared error is the square of the length of this line segment. So you get 1 minus 2 squared. Let's do the third example. Repeating this process, the error here also shown by this line segment, is 1.5 minus 3 squared. Next, we sum up all of these terms, which turns out to be equal to 3.5. Then we multiply this term by 1 over 2m, where m is the number of training examples. Since there are 3 training examples, m equals 3. So this is equal to 1 over 2 times 3, where this m here is 3. If we work out the math, this turns out to be 3.5 divided by 6. So the cost j is about 0.58. Let's go ahead and plot that over there on the right. Okay. Now let's try one more value for w. How about if w equals 0? What do the graphs for f and j look like when w is equal to 0? It turns out that if w is equal to 0, then f of x is just this horizontal line that is exactly on the x-axis. And so the error for each example is a line that goes from each point down to the horizontal line that represents f of x equals 0. So the cost j when w equals 0 is 1 over 2m times the quantity 1 squared plus 2 squared plus 3 squared, and that's equal to 1 over 6 times 14, which is about 2.33. So let's plot this point where w0 and j of 0 is 2.33 over here. And you can keep doing this for other values of w. Since w can be any number, it can also be a negative value. So if w is negative 0.5, then the line f is a downward sloping line like this. It turns out that when w is negative 0.5, then you end up with an even higher cost, around 5.25, which is this point up here. And you can continue computing the cost function for different values of w and so on, and plot these, right? So it turns out that by computing a range of values, you can slowly trace out what the cost function j looks like. And that's what j is. To recap, each value of parameter w corresponds to a different straight line fit f of x on the graph to the left. And for the given training set, that choice for a value of w corresponds to a single point on the graph on the right. Because for each value of w, you can calculate the cost j of w. For example, when w equals 1, this corresponds to this straight line fit through the data, and it also corresponds to this point on the graph of j, where w equals 1 and the cost j of 1 equals 0. Whereas when w equals 0.5, this gives you this line, which has a smaller slope. And this line, in combination with the training set, corresponds to this point on the cost function graph at w equals 0.5. So each value of w, you wind up with a different line, and this corresponding cost j of w. And you can use these points to trace out this plot on the right. Given this, how can you choose the value of w that results in the function f fitting the data well? Well, as you can imagine, choosing a value of w that causes j of w to be as small as possible seems like a good bet. J is the cost function that measures how big the squared errors are, so choosing w that minimizes these squared errors, makes them as small as possible, would give us a good model. In this example, if you were to choose the value of w that results in the smallest possible value of j of w, you'd end up picking w equals 1. And as you can see, that's actually a pretty good choice. This results in a line that fits the training data very well. So that's how, in linear regression, you use the cost function to find the value of w that minimizes j. Or in the more general case, when we had parameters w and b rather than just w, you find the values of W and B that minimize J. So to summarize, you saw plots of both F and J and work through how the two are related. As you vary W or vary W and B, you end up with different straight lines. And when that straight line passes close to data, the cost J is small. So the goal of linear regression is to find the parameters W or W and B that results in the smallest possible value for the cost function J. Now, in this video, we worked through our example with a simplified problem using only W. In the next video, let's visualize what the cost function looks like for the full version of linear regression using both W and B. And you see some cool 3D plots. Let's go to the next video.
Bueno, como verán, todo esto tiene mucha matemática por detrás, está explicado de la manera más simple posible, pero bueno, tiene su contenido, ¿no? Estoy mirando acá en YouTube si hay preguntas, acá también, bueno, vamos a seguir, vimos Intuition recién, ¿no? Intuition, entonces nos queda visualizando la función de costo. ¿Sí? Vamos con este video y después tenemos otro más, y un lab y una quiz. Y los escucho si quieren seguir o parar, eso me avisan. Si se la bancan, vemos el último tramo. Eso lo vemos en un ratito. Bueno, seguimos. Visualizando la función de costo.
In the last video, you saw one visualization of the cost function J of W or J of WB. Let's look at some further, richer visualizations so we can get an even better intuition about what the cost function is doing. Here is what we've seen so far. There's the model's parameters W and B, the cost function J of W and B, as well as the goal of linear regression, which is to minimize the cost function J of W and B over parameters W and B. In the last video, we had temporarily set B to 0 in order to simplify the visualizations. But now let's go back to the original model with all parameters W and B without setting B to be equal to 0. Same as last time, we want to get the visual understanding of the model function f of x, shown here on the left, and how it relates to the cost function j of wb, shown here on the right. Here's the training set of house sizes and prices. Let's say you pick one possible function of x, like this one. Here, I've set w to 0.06 and b to 50. So f of x is 0.06 times x plus 50. Note that this is not a particularly good model for this training set. It's actually a pretty bad model. It seems to consistently underestimate housing prices. Given these values for W and B, let's look at what the cost function J of W and B may look like. Recall what we saw last time was when you had only W because we temporarily set B to 0 to simplify things. Back then, we had come up with a plot of the cost function that looked like this as a function of W only. So when we had only one parameter W, the cost function had this U-shaped curve, shaped a bit like a soup bowl. That sounds delicious. Now, in this housing price example that we have on this slide, we have two parameters, W and B. And so the plot becomes a little more complex. It turns out that the cost function also has a similar shape, like a soup bowl, except in 3 dimensions instead of 2. In fact, depending on your training set, the cost function will look something like this. To me, this looks like a soup bowl, maybe because I'm a little bit hungry. Or maybe to you, it looks like a curved dinner plate. or a hammock. Actually, that sounds relaxing too, and there's your coconut drink. Maybe when you're done with this course, you should treat yourself to a vacation and relax in a hammock like this. What you see here is a 3D surface plot where the axes are labeled W and B. So as you vary W and B, which are the two parameters of the model, you get different values for the cost function J of W and B. This is a lot like the U-shaped curve you saw in the last video, except instead of having one parameter, W, as input in the J, you now have two parameters, W and B, as inputs into this soup bowl or this hammock-shaped function J. And I just want to point out that any single point on this surface represents a particular choice of W and B. For example, if W was minus 10 and B was minus 15, then the height of the surface above this point is the value of J when W is minus 10 and B is minus 15. Now, in order to look even more closely at specific points, there's another way of plotting the cost function J that would be useful for visualization, which is rather than using these 3D surface plots, I'd like to take this exact same function J, so I'm not changing the function J at all, and plot it using something called a contour plot. And if you've ever seen a topographical map showing how high different mountains are, the contours in a topographical map are basically horizontal slices of the landscape of, say, a mountain. This image is of Mount Fuji in Japan. I still remember my family visiting Mount Fuji when I was a teenager. It's a beautiful sight. And if you fly directly above the mountain, that's what this contour map looks like. It shows all the points that are at the same height for different heights. At the bottom of this slide is the 3D surface plot of the cost function J. I know it doesn't look very bow-shaped, but it is actually a bow just very stretched out, which is why it looks like that. In an optional lab that is shortly to follow, you'll be able to see this in 3D and spin around the surface yourself, and it'll look more obviously bow-shaped there. Next, here on the upper right is a contour plot of this exact same cost function as that shown at the bottom. The two axes on this contour plot are B on the vertical axis and W on the horizontal axis. What each of these ovals, also called ellipses, shows is the set of points on the 3D surface which are at the exact same height. In other words, the set of points which have the same value for the cost function J. So to get a contour plot, you take the 3D surface at the bottom and you use a knife to slice it horizontally. You take horizontal slices of that 3D surface and get all the points that are at the same height. Therefore, each horizontal slice ends up being shown as one of these ellipses or one of these ovals. So concretely, if you take that point and that point and that point, all of these 3 points have the same value for the cost function J, even though they have different values for W and B. And in the figure on the upper left, you see also that these 3 points correspond to different functions, F, all 3 of which are actually pretty bad for predicting housing prices in this case. Now, the bottom of the bow, where the cost function J is at a minimum, is this point right here, at the center of this concentric ovals. If you haven't seen contour plots much before, I'd like you to imagine, if you will, that you're flying high up above the bow in an airplane or in a rocket ship, and you're looking straight down at it. So that is as if you set your computer monitor flat on your desk facing up, and the bow shape is coming directly out of your screen, rising above your desk. Imagine that the bow shape grows out of your computer screen lying flat, like that. So that each of these ovals have the same height above your screen, And the minimum of the bow is right down there in the center of the smallest oval. So it turns out that the contour plots are a convenient way to visualize the 3D cost function j, but in a way that's plotted in just 2D. In this video, you saw how the 3D bow-shaped surface plot can also be visualized as a contour plot. Using this visualization tool, in the next video, let's visualize some specific choices of W and B in a linear regression model so you can see how these different choices affect the straight line you're fitting to the data. Let's go on to the next video.
Bueno, vamos a seguir un ratito. A ver, hicimos ¿no? La intuición, visualizando, nos queda visualization examples, ejemplos. Y hay un lab y un quiz. Ahora voy a ver el canal de YouTube, si hay preguntas. Hay 11 personas conectadas. Les voy a pasar un par de avisos parroquiales, ¿sí? El primero de ellos es que les quiero informar que el Centro de Graduados va a abrir una sede en el Centro de Buenos Aires. Obviamente esto puede ser interesante, utilidad para la gente que vive en el área metropolitana de Buenos Aires. Quien les dice en algún momento se da la posibilidad de abrir alguna sede en otra ciudad. Nosotros somos de acá de Buenos Aires, entonces bueno, vamos a tener un lugar donde la idea es dar cursos presenciales, atender a la gente. No sé si hay gente acá de Buenos Aires, imagino que sí, que debe haber unos cuantos. Así que bueno, eso sería el primer tema. Y el otro es, si hay gente que está interesada en tema trading, nosotros tenemos una herramienta que estamos promocionando para hacer trading en Forex. Yo la adquirí, se llama PipGrabber, la verdad que me está yendo muy bien. Es mi hijo el que está distribuyendo esa herramienta. Él le permitió largar el trabajo, se está dedicando a full a eso, así que le está yendo muy bien y ya tiene bastante gente del centro que ha venido a las charlas. Y vamos a dar una charla, creo que el 28 de julio, así que los invito si quieren estar mostrando la herramienta, los resultados y todo. Obviamente hay que hacer una inversión, pero la verdad que da resultados muy buenos, ¿no? Obviamente hay que tener una buena gestión de riesgo, hay que tener cuidado. Bueno, así que vamos con ejemplos, visualizando ejemplos, ¿sí? Vamos con esto.
Let's look at some more visualizations of W and B. Here's one example. Over here, you have a particular point on the graph J. For this point, W equals about -0.15 and B equals about 800. So this point corresponds to one pair of values for W and B that yields a particular cost J. And in fact, this particular pair of values for W and B corresponds to this function, f of x, which is this line that you can see on the left. This line intersects the vertical axis at 800 because B equals 800, and the slope of the line is -0.15 because W equals -0.15. Now, if you look at the data points in the training set, you may notice that this line is not a good fit to the data. For this function f of x, with these values of W and B, many of the predictions for the value of y are quite far from the actual target value of y that is in the training data. Because this line is not a good fit, if you look at the graph of J, the cost of this line is out here, which is pretty far from the minimum. It's a pretty high cost because this choice of W and B is just not that good a fit to the training set. Now, let's look at another example with a different choice of W and B. Now, here's another function that is, still not a great fit for the data, but maybe slightly less bad. So this point here represents the cost for this particular pair of W and B that creates that line. The value of W is equal to 0, and the value of B is about 360. This pair of parameters corresponds to this function, which is a flat line because f of x equals 0 times x plus 360. I hope that makes sense. Let's look at yet another example. Here's one more choice for w and b, and with these values, you end up with this line f of x. Again, not a great fit to the data. It is actually further away from the minimum compared to the previous example. And remember that the minimum is at the center of that smallest ellipse. Last example. If you look at f of x on the left, this looks like a pretty good fit to the training set. You can see on the right, this point representing the cost is very close to the center of the small ellipse. It's not quite exactly the minimum, but it's pretty close. For this value of w and b, you get this line f of x. You can see that if you measure the vertical distances between the data points and the predicted values on the straight line, you get the error for each data point. The sum of squared errors for all of these data points is pretty close to the minimum possible sum of squared errors among all possible straight line fits. I hope that by looking at these figures, you can get a better sense of how different choices of the parameters affect the line f of x and how this corresponds to different values for the cost j. And hopefully, you can see how the better fit lines correspond to points on the graph of j that are closer to the minimum possible cost for this cost function j of w and b. In the optional lab that follows this video, you get to run some code. And remember, all of the code is given, so you just need to hit Shift-Enter to run it and take a look at it. And the lab will show you how the cost function is implemented in code. And given a small training set and different choices for the parameters, you'll be able to see how the cost varies depending on how well the model fits the data. In the optional lab, you also can play with an interactive contour plot. Check this out. You can use your mouse cursor to click anywhere on the contour plot, and you will see the straight line defined by the values you chose for the parameters w and b. You see a dot appear also on the 3D surface plot showing the cost. Finally, the optional lab also has a 3D surface plot that you can manually rotate and spin around using the mouse cursor to take a better look at what the cost function looks like. I hope you enjoyed playing the option. Now, in the main regression, rather than having to manually try to read a contour plot for the best value for w and b, which isn't really a good procedure and also won't work once we get to more complex machine learning models, what you really want is an efficient algorithm that you can write in code for automatically finding the values of parameters w and b that gives you the best fit line that minimizes the cost function j. There is an algorithm for doing this called gradient descent. This algorithm is one of the most important algorithms in machine learning. Gradient descent and variations on gradient descent are used to train not just linear regression, but some of the biggest and most complex models in all of AI. So let's go to the next video to dive into this really important algorithm called gradient descent.
Bueno, la verdad que descenso del gradiente es un temazo, ¿no? Capaz que es un poquito tarde, después me dicen ustedes si se la bancan o no. Bueno, vamos a ver entonces el lab, ¿sí? Antes que eso les voy a volver a pasar, porque hay gente que se agregó ahora. Para la gente que se agregó ahora, les paso el link. La idea es que den el presente por ahí, poniendo nombre y apellido. Así les podemos tomar el presente. Y vamos a YouTube. YouTube también les pasamos. Así a veces podemos estar en contacto. Muy bien. ¿Qué más? Seguimos. Vamos con el lab. función de costo, lo que estuvimos viendo recién. Objetivo, vamos a implementar y explorar la función de costo para la regresión lineal con una variable. ¿Sí? Herramientas, vamos a ver NumPy, una biblioteca para computación científica, Matplotlib, una biblioteca para graficar datos, y rutinas de plotting local, bueno, hay una cantidad de bibliotecas, ¿sí? Que están, digamos, funciones agregadas. Bueno, vamos a ejecutar. Ahí está. Entonces, bueno, tenemos estos dos puntos, el tamaño y el precio. Esto lo vimos antes. Un ejemplo. Vamos a calcular el costo, que es la fórmula que vimos arriba, la sumatoria de las diferencias elevadas al cuadrado entre el valor que predice el algoritmo y el objetivo, ¿no? Y el dato que tenemos. ¿Sí? Bueno, tenemos esta función que calcula el costo, que implementa esa fórmula. Bueno, y vamos, bueno, acá nuevamente, como les digo, repite la teoría, está muy bueno. Estas Jupyter están muy bien hechas. Yo les digo que empecé en mis cursos a hacerlo así. Hice un par, sí, impresionante el tiempo que lleva, o sea, el trabajo que tiene, el desarrollo, pues está muy bueno realmente. Y todo esto está hecho con látex, ¿sí? Que digamos, ¿cómo se dice? El Markdown interpreta látex. Así que toda esta formulita está muy buena. Bueno, el intuition, ahí está, ¿ven? Que yo la puedo ir modificando esto. En función de lo que modifico va cambiando, ¿ven? Está muy bueno, muy bien armadito. ¿Ven? Va cambiando acá, voy cambiando acá, este valor, y va trayendo otro dato, ¿ven? Bueno, la verdad que está muy piola, para jugar, para divertirse un rato. Muy bien hechito. La verdad que Python es una herramienta espectacular. Bueno, ahí tienen todos los valores. Pueden ir jugando con esto, ¿no? Y ahí les arma la función. Bueno, vamos al quiz. Para regresión lineal, ¿no? Que la función, que es de W de X, con los parámetros WX más B. ¿Cuáles de los siguientes son inputs, o sea, los inputs o los features que se alimentan al modelo, y el cual el modelo espera de hacer una predicción? MX, WB o XY. Voy a mirar acá en YouTube a ver si alguien contesta. Bueno, en YouTube todavía falta, ¿no? Pero si alguien contesta, voy a mirar. Voy a mirar acá. Bueno, Nadia y Adriano dicen, a ver si llegamos en YouTube, si hay alguien. No llegamos todavía, bueno, perdón, hay un delay entre YouTube. Dicen la X, ¿no? Y Jonathan también. Bueno, creo que sí, ¿no? La X. Bueno, y para regresión lineal, si encontrás los parámetros W y B de tal manera que J de W y B es muy cercano a 0, ¿qué concluiría? Concluimos que los valores seleccionados de los parámetros W y B causan que el algoritmo se acomode al ser entrenamiento muy bien. Nunca es posible, tiene que haber un bug en el código. Los valores seleccionados de los parámetros W y B causan que el algoritmo se acomode al conjunto de entrenamiento de datos muy pobremente. Bueno, Fede está contestando, Nadia, también hay consenso por la 1, ¿no? Bueno, como les decía, ojo con los headhunters. Uy, ¿qué pasó? ¿Qué me chingamos? X puse. Inputs or features that are fed in the model with expected to make a prediction. Está bien.
En la segunda te olvidaste de marcar.
Ah. Claro. No, ya me estaba poniendo mal, dije, ¿qué chingue? Bueno, los headhunters van a tener un... Me faltó responder al segundo. No, digo, ya, puede fallar, pero a ver, acá era... Acá, no, pobremente no acá. A ver ahora... Bueno, para los headhunters, parque de esta parte. 100%, bueno, ahí está. ¿Estás, Carla, ahí todavía? Buenísimo. Che, Carla, ¿querés mostrar algo de lo que hiciste o no tenés nada ahí para...?
Está en preparación todavía.
Bueno, Carla ya hizo su algoritmo, ¿no? De clasificación con Computer Vision. Vos, Carla, en cualquier momento tenemos que darte el certificado profesional de Deep Learning, ¿eh?
Sí, obvio, lo estoy esperando.
Tenemos que hacer una ceremonia de colación de grados. Bueno, pregunta. Todavía hay 29 personas conectadas acá. ¿Seguimos con descenso del gradiente o qué dicen? Lo dejamos sometido a la audiencia. Nos quedan 1, 2, 3, 4, 5 videos. 6, hay que fumarse. No puedo, dice Joaquín. Bueno, que digan ustedes. Si quieren, cortamos acá y esto se lo ven por su cuenta. No tienen mucha ganas, ¿no? Ah, de Coursera. Sí, bueno, miren, Coursera son, miren, les voy a mostrar. Son más o menos, son 10.000 cursos, hay un montón. Y de variadísimos temas. O sea, es imposible hablar de un solo tema. O sea, de mostrar todo. Pero básicamente nuestros planes tienen acceso a todos los cursos. A ver, lo estamos, inicio del programa. Por ejemplo, este que estamos ofreciendo, el plan plata. Plan plata, ¿ven? Son 9.665 cursos. Es impresionante lo que está creciendo, o sea, bueno, Walder, dale. Bueno, son montones. Hay de distintas universidades, hay de Python, hay de un montón de temas. Si ven el catálogo, fíjense, como para que vean. Por acá, acá. Fíjense, hay de artes y humanidades, 337 cursos, de negocios, 1.273 cursos, de ciencia de la computación, 971 cursos, de ciencia de datos, 705 cursos, de tecnología e información, 549 cursos, de salud, 537, de matemáticas y lógica, 122, de desarrollo personal, 389, de ciencias físicas e ingeniería, 420, de ciencias sociales, 551, de aprendizaje de un idioma, 140. Sí, sí tiene que haber de todo. Lo que pasa que, bueno, la realidad es que nosotros vamos seleccionando y nos ponemos a mirar un curso. O sea, desde que nosotros tenemos en Coursera el curso hasta lo que transformamos en un curso nuestro, bueno, hay un proceso. Hacemos esto, ¿no? Empezamos a mirar, vamos armando materiales. Por ejemplo, los que yo recomiendo son, por ejemplo, los cursos de Google, que son certificados profesionales. Y eso sí, hemos trabajado un montón en ellos, coursera.org/Google. Y son cursos muy buenos que empiezan bien de cero. Por ejemplo, tienen marketing digital, data analytics, ya lo tenemos todo pasado al español, con una profesora muy buena. Lo mismo que project management, eso da Marina Siliti. De UX también lo estamos trabajando. Sí, de IT support, ese es Javier, que está por acá anotado. Y el de Google, el de Python, es el que estamos dando los sábados con Emiliano. Después de IBM tienen más de 100 cursos de distintos temas certificados profesionales. Hay de Facebook. Es imposible hablar, digamos, de escribir todo, pues son miles y miles de cursos. Y la realidad es que nosotros estamos armando, ya hay una comunidad muy fuerte, queremos fortalecerla, y la idea es que cada uno es el principio de una asociación civil. Pague una pequeña cuota, una cuota accesible, y con eso de alguna manera, además de tener un servicio, hace que todo el sistema funcione y que está bueno, ¿no? Está bueno que uno pueda tener un lugar donde preguntar, o un compañero que está haciendo otra cosa, que aparezcan proyectos, que, digamos, hoy prácticamente nosotros si necesitamos algo, lo mandamos a la comunidad. O sea, queríamos una persona que venga a limpiar, no sacamos aviso, nada, apareció una chica que además es una capa porque está trabajando cursando informática, entonces nos ayuda en la oficina. Y así, ahora por ejemplo estamos necesitando un arquitecto para la nueva sede y seguro que vamos a mandar un aviso. Y está bueno esto, que haya una comunidad, un lugar donde uno tiene una referencia. Así que bueno, no sé si hay más preguntas o preguntas puntuales, porque, digamos, yo puedo hablar horas del centro de graduados, pero no sé exactamente qué es lo que quieren saber. Pero básicamente el sistema es ese que les dije. Tenemos licencias que se van transfiriendo, que van rotando, y bueno, puede ser que alguna vez quieran entrar y está lleno, hay que esperar un poquito, pero bueno, básicamente uno se la pasa la mayor parte del tiempo mirando los videos, y la verdad que son temas muy buenos, y nosotros vamos generando material adicional, consultas y material para poder ayudar. PayPal, Adriano, lo mejor es por PayPal. Igual creo que por Mercado Pago pueden pagar. Me parece que no les sirve lo de los pesos. Pero lo mejor es PayPal. Mirá, PayPal es un sitio internacional, Mercado Pago. Lo que pasa es que Mercado Pago no te toma los pagos en dólares, o por lo menos nosotros lo trabajamos en pesos. PayPal te lo toma en dólares, y para la gente de afuera es más conveniente, me parece. Para la de acá no, porque para nosotros está prohibido PayPal. Vos no podés pagar PayPal con una tarjeta argentina. Tenés que hacer todo un subterfugio, cargar por saldo comar. Para nosotros es un problema realmente. Bueno, lo tenemos que usar, no tenemos otra. No sé si en YouTube hay preguntas. No, bueno. Sigamos, dice Rubén Bermúdez. Y Western Union, sí, Western Union se puede usar, pero Western Union tiene un par de problemas. Primero que es todo un engorro, entre que vos mandás el pago, hay que ir a buscarlo. O sea, si vos vas a pagar, por ejemplo, la temporada, $259, no hay ningún problema. Pero después el otro problema es que con el cambio argentino no le sirve a nadie, o sea, te matan. O sea, hoy, por cómo está la cosa, no sirve, no te conviene. Así que yo no recomiendo Western Union, recomiendo toda la vida PayPal. Y si no, puede ser por Mercado Pago, creo que se puede pagar, y si no, tenemos PayPerTick, que con una tarjeta afuera se puede pagar. Pero siempre tiene el mismo problema, que nosotros le vamos a cobrar en pesos, y ustedes no van a hacer el cambio de lo que vale el dólar para nosotros, sino lo que vale el dólar oficial, que es una entelequia, es decir, no se consiguen dólares oficiales. Entonces, el dólar oficial vale poco, y en peso, dividido por algo que vale poco, le va a dar muchos dólares, entonces no les sirve. Es que no se puede, es ilegal en Argentina, no se puede transferir de afuera para acá, no permite eso nuestro sistema. Tendríamos que tener nosotros una cuenta afuera que no la tenemos. Pero insisto, PayPal es muy sencillo, es una cosa fácil, cualquiera es accesible a PayPal, no hay ningún problema. Bueno, no sé si hay más preguntas. Tardío llegó la sugerencia de Rubén Bermúdez, así que señores, entonces ahí tienen los videos igual, los pueden ver en esto que prepararon Carla y Emiliano. Le agradecemos nuevamente que se hayan tomado el trabajo de pasarlo a español, y bueno, nos veremos. Obviamente estaría bueno que se suscriban y que nosotros estamos dando esta charla, ¿sí? Esta charla. La verdad que para nosotros realmente es muy costoso poder dar esto. Dale, Walter, buenísimo. Dar esto como curso gratis, o sea, estaría bueno, pero no tenemos, digamos, tanta espalda como para hacer eso. Entonces, yo entiendo que la gente viene, algo gratuito y quiere seguir, está bárbaro, pero bueno, no es sustentable para nosotros, eso quiero que entiendan. Entonces, usamos estas charlas como promoción, y sí, nuestros suscriptores, los que pagan los planes, digamos, de cursos, los que compran los cursos, tienen los cursos. ¿Tá? Bueno, muchachos, espero que les haya servido, que les haya gustado, que les haya picado un poco el bichito de la curiosidad por el Machine Learning, por Coursera, y nos veremos en alguna otra. Igual está en el grupo de WhatsApp, ¿sí? Entonces vamos a cortar acá, y nos veremos en alguna otra ocasión. Espero que muchos de ustedes tengan ganas de suscribirse, de comprar algunos de nuestros cursos. Bueno, Walter, ya hablaremos. Buenas tardes a todos, que terminen bien, que pasen un lindo fin de semana, y éxitos. Chau, chau.